everybody for joining, and we will start in the next 4 to 5 minutes, maybe. Until then, all of you can prepare your maybe note takeover. You'd like to take your notes down and have all the material ready, because we wouldn't want you to miss even a single minute. So yeah, a glass of water. And what else would you suggest, Bertil? How can people get through a coding session in the most efficient way?
Sorry, can hear you?
Any tips for the audience as to how they can most efficiently get through this particular coding session?
Most efficiently, I think the one thing that'd be useful if you have it, it's not everybody's has access to that, is if you work for a company that has some data, have that data available so that you can try the same kind of code on what you're trying to do. I'm going to share the code I'm using on GitHub during the session, so that can help. The second thing that can help, so having code would be having some data would be handy during the coding sessions. There's going to be a little extensive discussion on how to run experiments. So thinking about if you're the client of a service, if you work for a certain company, if you have frustration with how a service online works and you want them to change something, think about what that change could be. That there's going to be a couple of moments where we can discuss how those changes are done, what the company probably thinks around that change, what is the goal they have. So those would definitely be super helpful during the session. All the content is going to be shared, all the code or the slides are going to be shared afterwards. So don't worry about taking screen notes or things like that. That should make sense. If you have any comments, feel free to make sense. And I believe that this is recorded, so I don't know it's going to be made available to participants afterwards, but that should be very helpful. There's, I've watched a lot of coding videos, so I know how it is. There's a moment someone like just does something and you're like, wait, what did happen? Because like it doesn't work that smoothly on my end. So hopefully we can go through enough details that you don't have that many surprises. But like video recordings should be helpful to just go back and realize, oh yeah, there's a semicolon there, or like there's one option that I haven't clicked on this page. Hopefully we don't have too much of those, but that can help meaningfully if you're trying to go through those.
Perfect. I hope everybody was able to make a note of what Bertil just mentioned as to how to make the most out of this session, because this is not just a regular 1-hour webinar, it is a coding session. So yeah.
Yep, about half of the content will be me going through code, both notebook and production code. So hopefully I get into enough depth that you can, like if you try yourself, if you have any difficulty, there's going to be a moment where you recognize this makes sense. So yeah, hopefully there's going to be helpful for everybody. What I'm going to try to do, and I cannot make promises on the first one. Hopefully, Chandra can keep me honest on both. I've been told that I speak too fast. That is absolutely not true. You're not listening fast enough. But if you think I'm generally speaking too fast, please let me know. That is a problem I've been told about before. I wouldn't be surprised. I'm trying to just remind myself. I've got like stickers everywhere saying stop speaking so fast. One is here and one is here, if you want to know exactly where they are. So if I'm looking there, I'm like, oh, I'm speaking too fast. The second one is I'm going to try to just take a break, look at the comments, just not be too one way during the whole session. But if you have a question around big, high-level philosophical questions, hopefully we'll have time in between segments or at the end to discuss them in a phase. So feel free to write it down. If you have like, I didn't hear you use the word, it sounded important and I couldn't hear what the word was, feel free to interrupt me, because understanding questions like they're better fixed right on the spot. If you want to say, oh, I like Bayesian techniques, more than happy to like go a bit through what it is, but that's more of a philosophical question. So there's not much I can do while live coding to explain what it is.
Okay,
cool.
Okay, Bertil, so I'd maybe start and then hand it over to you. Yeah.
Cool.
So, all right. Thanks everybody for taking the time on a Saturday and getting on this specific coding session. We have Bertil with us, who is a seasoned professional with a rich background. So, Bertil has experience spanning across various roles and a total of roughly 13 to 14 years of experience in the industry. With
24 now.
oh, I'm so sorry,
No, it's,
24.
it's I'm trying to lower that number, but it's harder that way.
Wow. Sorry for that. So Bertil has 24 years of experience, and I'm just going to be mentioning a couple of sort of roles that Bertil has specialized in, starting with being a data scientist at Facebook to being the head of data science for Booking.com, all the way up to his current role, which is an experimentation advocate at Split. So Bertil brings in a wealth of experience in data science and experimentation, as I'd like to say it. So let's basically discover valuable insights and expertise as Bertil shares his journey and knowledge in this very exclusive webinar slash coding session. Over to you, Bertil. The virtual stage is all yours.
Oh, thank you so much. So yeah, I've had more than 20 jobs over 125 years. So it's been a whirlwind. The one commonality among all those is that people wanted to make decisions with data, and that sounded obvious. Pick whichever is the best option. But I've discovered it's not that trivial. My job title is Experimentation Advocate, and I was like, what does that mean actually? It seems that it is telling people, this thing that we're doing for the last 200 years, and that has unleashed all the medicine, all the science, the industrial revolution. Like, we managed to go to space with the kind of approach we have. I'm supposed to advocate for it. I'm supposed to tell people it's cool. Like, how did they not notice? Like, just look around you. It's been a whirlwind of progress thanks to that very simple method, very simple idea. But it was difficult 200 years ago to argue for it. It is still difficult to argue for it. There's still some pushback. There's still some misunderstanding. And I'd love to go through both the technical issues around, like, I've got data sets and I want to go from that data set to, like, it is statistically significant. I want to make decisions, but I don't know exactly what is the right way to make a decision. Or I have some intuition of why things are broken. I have some intuition of how to improve things. How do I build an organization that can make sense? Hopefully we can go through both the principles and the code and like some technical issues around the code, not everything, because nothing is more creative than a computer trying to prevent you to do your job. There's two small prerequisites for the class. The first one is some familiarity with Python. It's not like nothing too in depth, but if you know what is a notebook, if you know what is a library, that will help. I will mention it as we go. If you're not familiar, just raise your hand and more than happy to go through those details. But essentially, Python is like English with spelling, so it wouldn't look, if you're not familiar with it, it wouldn't look unusual. And the second thing that I think is helpful is some familiarity with how large technology companies work, because that's going to be a lot of my reference. There's an example of A/B testing in distribution company, in delivery company, in like not so technical company, but tech company are the big example, where you have the most example of A/B testing, large amount of A/B testing, interesting stories, interesting impact, and so I think that's the best thing. Before we go into the meat of it, as you can see on the screen, on the corner, I'm using a service called Mentimeter, which is a way to use some presentations that are not just me talking to you, but have a little bit of interactivity. I see a dozen of you have used the QR code, or go to menti.com and use the code 84261274. There's no bigger QR code on your screen. You should be able to scan that so that your phone goes on like a website it's just for you to vote on a couple of questions. There's going to be one session now so that I know a little bit better who I'm talking to. I'm going to reuse that a little bit later in the session, but towards the end, so you've got a couple of hours to charge your phone if it's not charged. But I'd love you to start using that so that we can have a little bit of interactivity and so that we can understand a little bit better who you are, what you're trying to do. First question I want you to ask, so I set my expectation, is how familiar are you with A/B testing? There's no wrong answer. I've chosen roughly 4 possibilities. but I don't know if this is the one. One option is you've heard about it, like you've heard people use A/B testing, but you've never actually seen that in practice. The second option is you've actually been in a meeting where someone said, here's an A/B test, here's the results. You were like, that's cool. So apparently one option is better than the other, but I don't know what that means. I don't know how those numbers come out. Third option is you've actually run a few tests yourself. Either you were the team that were judged by the test, or you were the analysts that run the test and process the data, but what came out felt wrong and you're not super familiar with it. My last option is you've built your own A/B testing platform, in which case I hope you're going to help me to answer some of the questions. I haven't not seen anyone answering that question, but that would be really, really helpful. So I mostly have people who say that they have heard about it, not necessarily people who actually seen A/B testing results in a meeting. So that is both worrisome because it means that your companies are not doing A/B testing, which is not great. But it also tells me just to make sure that go through the basic. That's what I was told. This is mostly an introduction class. This is for people who are not super familiar. At the very last slide, I'm going to go into a bit more detail into like advanced techniques. So if you're more someone who's run and want to learn, I'm going to go through some of the examples. But I'm definitely going to try to go at the very basic of why we run A/B testing and why it is what we're trying to do. I've got 15 or so participants in the that have voted and that people have registered on Menti.com. I don't know if everybody's in voted for Menti, but it's really going to be helpful to have that. So the outline, as I mentioned, is first is why run A/B tests? What's the point? When are we trying to run those? Are there alternatives that are better? Second is run an actual A/B tests on existing data. So the data, for many reasons, is simulated data. It's fake data I generated myself. And then I'm going to do something that is going to sound very strange. But when you run an A/B test, you actually compare two things that are different, which we call A and B, hence the name. And I'm going to ask, what happens if you compare two things that are meant to be equivalent, A and A? That sounds very counterintuitive. It actually is the core idea behind some very abstract statistics. It's, for me, the best way to explain what the test is actually doing. And what I think is going to help you explain to others what is really A/B testing, because there's some statistics and there's some Greek letters. It all looks very abstract. It doesn't, all that abstraction doesn't help, but hopefully this weird idea of running a test is going to help make sense of that. Then we're going to go into a bit more like understanding of why we run a test and the kind of practice that goes around it. And then if you're like, okay, I have like a little bit of code that works, but I'm not asked to run a little bit of code that works. I'm asked to make something that is formal, that is actually solid, that I can use for my computer. What are the kind of steps? What are the kind of things I need to make sure so that it doesn't just run once on my laptop when I run it, but like it is a service that the rest of my large technology company can use. We're not going to go into like detailed way of doing this, that would take a lot more than 3 hours. But we can go into a little bit of the kind of steps, the kind of precaution you have to do, the kind of types of service that you need, why you need to have those extra layers on top of what you can see on my screen. And that seems to work fine when it's on my screen. And one thing that I finally want to go through, because that's, I think, really important, is go through detailed power analysis. Because if you ask anyone who's running A/B testing, like, what is it that you're supposed to do? Everybody will tell you, before you start running an A/B test, run power analysis. Always, always, always. That is a very important step. That is a step that is kind of, you have versions online that kind of show you, oh, you know, here's the minimum detectable effect, which is like an interesting concept. But unless you go through what actually is power analysis, what does it look like? What is there's a curve, a power curve. What is it shaped that way? What are the different elements of the curve? Why are they important? It won't necessarily make sense, and it will allow you to come back to your people saying, it's not that I'm saying the power is too small, is that if you run it that way, here's what's going to happen to us, and here's why it's going to be disappointing for everybody. Try to rethink how you run A/B testing. And finally, I'm going to talk a bit about the confusion matrix, which for me is the most important argument. The name itself sounds confusing, but it is basically, you will hear this number 5% as the significance threshold or the false positive rate. A lot of people think it means something. It means something else. That distinction is really important for us to establish, which is why I'm going to show you a simple graphical tool, a 2x2 matrix. Like, you cannot imagine something simpler, that you can show people, here's what's happening. Here's what it's doing. You think that these two numbers are 5%. This is not the case. Here's the numbers that are 5%. Here, the number you're looking at are actually quite different. And that very simple mathematical trick is going to allow you to say, Here's why we should run better A/B testing. Here's why we should pay more attention to these aspects. Here's the kind of things that we need to do for A/B testing. Finally, if you go through A/B testing, you're going to hear one word more than any other, and that is breakdown. Because people try an idea, the idea doesn't work, and they're very frustrated. And because of that, they're like, I need to understand what's happening. Could you break down the results by categories? Could you explain to me? The intuition is really worthwhile. It's definitely something you want to encourage. It's definitely something you want to automate. There's some handful of issues around it, but I'll show you a little bit how you can do it. It's reasonably easy to do. It's just very tedious. And what are the kind of things you want to pay attention to around this question of categories? There's a lot more complication than just categories. It's one example, and I think the most relevant one, the one that you will. I have not seen a test where when you show the result to someone, their action was not immediately, can you do a breakdown? So I'm 100% confident this is going to be something that is very helpful when you run an A/B test yourself and when you show results. That's the overall outline. We have 3 hours. Some of you are going to beg for a break. I'm assuming Chandra is going to decide at some point that I've been speaking too much and that she's tired of hearing my voice, so she's going to tell me to have a break. I'll be very happy to have a break. I don't know exactly when. We'll see as the time goes, hopefully after about an hour and a half, so that we can all just have a little bit of tea and well, let's go through it. One of the question that you will hear the most when you're discussing the possibility of having someone work on A/B test is why A/B test? The idea of an A/B test is very simple. You have a service, let's say a website that runs, let's say the example of an e-commerce website, because that is the easiest thing you can imagine. People come on your website, they see you have nice shirts, you put the shirts in your cart, give your payment information, delivery of the shirt, everybody's super happy. And then you think about an improvement. The improvement could be one of many things. Whenever you buy something and you add to the cart, you have like three or four examples. And that might slow down. So you say, what if they select a shirt and immediately they pay and we don't have the upsell? And then the team that does the upsell is like, when people buy a shirt, we can sell them a skirt, we can sell them shoes, we can sell them belts. There's like a real possibility to upsell. So if we skip that step, it's not super valuable. So you have a service that works. You have a feature, a change, an improvement. And an A/B test is saying, rather than show the improvement to everybody, when people come on your website, randomly assign them to one of two options, control or treatment, or A or B, but let's call it control treatment. Control is what was being available until now. It's the champion, is the default, is what the website as people know them. For half of them, they see what they saw last week, they saw the same version. And for the other half, they see the new version, the version with directly skip the cart, or the version where you have a new way of payment, or like free delivery, whatever is the change that you want to do. And you run a website with two versions of the website available randomly to one person or another for several weeks. Why would you do it that way? As opposed to the default way, which is you have a better version of the website, you think it's better because you decided it was better, and you just implement it for everybody. And that way you can see what happened last week and what happened once you've done the launch, and you look at conversion rate going up or any kind of change being meaningful. Why A/B test? Why go through this process of splitting the website in two and like showing something quite different? So one person has said that A/B test is to lose money or bad user experience, I guess to avoid losing money or bad user experience. That is an interesting idea. If the idea is bad, you probably is going to notice it because you have the website as running, you start your launch, and then you compare what happened before and what happened after the launch. If something goes bad, then you notice that you're losing money or that users complain more. To check the impact of difference between the two measures of features. That is roughly the same idea, which is when you A/B test, you have before, when you don't have before and after. So when you A/B test, you avoid having to, what happens if you launch without an A/B test? That's probably the easiest way to think. you have a website that works well, you do a change, then stats on the website are not really great. The overall conversion rate goes down. You have two options. Either you decide, well, the change isn't good. At least that's what a lot of people in the web company are saying. But a team that worked on the change is like, no, our work is great. We've looked about it. We did a lot of studies. Users were saying we have to click too much, so we reduce the number of clicks. That is a good change. And they're going to defend the idea. But they don't have any argument to defend themselves. So some of you say before launching, we should check. Absolutely. Before you run this idea, you should do some user checking. You should figure out that this is something that people actually understand. This is something that people make sense. For instance, I worked at a company that introduced Apple Pay. We didn't introduce Apple Pay because we thought it was nice. We introduced Apple Pay because half of our users were like, for the love of everything that is holy, please, can I have Apple Pay? I really want it. So there was some user testing before. But what happened for that change, and what happened for every single change you have, is if you release it without proper control, if you do, here's what happened until now, and then everybody sees a new version of the website, and whatever stats go down, some people are going to say, this is because of the change. And some people are going to say, no, a change is good. There's another factor. The weather's different. People stop using their mobile. There's another company that has done some rebates, and so they're competing against us. The company was in the press, and so they've heard about us differently. You're going to see a lot of those arguments. The reason to use A/B testing is indeed to check the impact between what happened with and without the change, but to check the impact with nothing else. The users are randomly assigned to one or the other, so presumably they're the same. The users are the same time, so it's not about the weather. The users are from the same country, so it's not about currency, or it's not about language. The only difference between control and treatment is that change. If you do before and after, there's so many other changes that you end up with disagreement. And so one of the things that A/B testing does is that it allows agreement. If you see a difference between control and treatment, you know that it is because of that change and that change only. It's not because of the weather. It's not because of something else. So someone says to control for all other external effects. That, I think, is the closest answer to what that makes the most sense, is to control for other external effects. Someone says to improve the website. That is true. It's not the effect of one test. It is the effect of one test allows you to say, here's, this change was helpful, this change wasn't helpful, and gradually you're going to improve the website as you go. But one single A/B test, if you say that whatever's coming out is bad, it's not going to improve the website. It's going to avoid some bad effect, but that's about it. To show a data-backed approach to which was better. That is true. That is true. This is also an argument that would work with before and after. You can say before and after is also data-backed. The difference between A/B test and before and after is that A/B test is entirely control. Data-driven decision making improved effective performance. Same thing, same idea. It both before and after an A/B test would be data-driven decisions, but one has the ability to have some control. The best way to respond to someone who says, we can do before and after test, A/B tests are not necessary, is to say, actually, you're always testing. Every release is a test. The difference between your release without an A/B test and release with one is that the release with an A/B test has proper control. We can, if there's a difference between a control and treatment, it is because of the change you made. If you do a before and after test, you can have seasonality, you can have competition, you can have the press that somehow messes with it. Another benefit of A/B test is that you can isolate novelty. You can, if someone is like, oh, this is a new page, I'm going to look at it. Because people see the new page at different time, you can say this is clearly the effect of seeing the page for the first time. One other effect that people don't think about too much, but is incredibly valuable, especially for video games and social media sites where people are quite intensely attached to. When you launch a video game, the first people playing are the people developing the game, and as soon as there's some private beta release, and there's some people who pay to get an early version of the game that is not completely ready, and then on the day one, you got people who spend a lot of time playing video games, are really attached. But rapidly, after a week, after a month, after a year of your video game being available, anyone who wanted to play has already played. The players who are left are the players who are less engaged, less excited about your game, less excited about your studio. Maybe they're not as much gamers, maybe they're not as fast or as competent, and you have completely different users. If you say, I'm going to release a game, let people play for a month, and then I'm going to introduce a new payment feature, introduce a new feature, and then look what happens that second month. You're not just measuring that new feature, you're also measuring the fact that the players are completely different the second month compared to the first one. Because the players who played in the first month, they've already finished your game, they're not coming back, or they might, but different. Same thing for social media sites. The people who were on Facebook in 2007 were people who studied at Harvard. They're not the same now. So if you compare, like, what is your ability to understand English between now and 2007, it's not going to be the same. And those changes are gradual, but they can have some meaningful effects on a lot of cases. If you do an A/B test, people connect on the same day, people connect in the same week, all those effects are quite different. The second thing that is other than those controls around novelty and seasonality and competition that is important is you can adjust for differences. If you have a control and treatment effect, you have two populations of users that when you launch the system could have been available the week before. And so it's not just two groups that because of randomness should be equivalent. You can actually check what they did the week before. You can check that the week before they actually had some small differences between control and treatment by accident, and you can still adjust for those. It's a technique that is quite advanced, but all that wouldn't be possible with a before and after test because the two groups that you compare are not the same exact people. So if you happen to have one VIP customer that buys a lot of the dresses that you sell on your website, you can actually tell, wait, no, that customer should not be in that. We've known that customer for a while, so you should exclude them. And it's easier to have those kind of checks after the fact when you do an A/B test than when you do a before and after test. But the one benefit of this argument of don't release as it is, think about whether you have proper control. Think about all the factors that can influence. Think about all the arguments that are going to pop up as soon as like your test is not successful. All the infighting is an A/B test or a random control trial, to take the scientific word, is the one technique that proves causality unambiguously. What is causality? What is unambiguously? Causality is if I do something, something else happens. It's not just that it happened afterwards. I created it. When you talk about causality, one of the examples is if you look at the data, it seems that wearing sunglasses makes you have sunburns. If you know anything about how things work, you're like, no, that sunglasses don't provoke sunburn. I put my sunglasses on and the next day I've got sunburn, but it's not because one caused the other. I put sunglasses because it's sunny and it's sunny, therefore, like it's not working that way. A/B test says I've changed something and then people behave differently. That connection is direct. It's not a false correlation. It's actual causal effect. And that is really important if you want to say, I want to have better customer service. It's going to cost us millions because we need to have staff. They need to be nice to the customers. They need to have the credits and the budget to actually give them rebates, make sure that things happen well. That means that our company has better retention. Customers are more likely to come back. We make more money overall. You need to have causal relations when you have that kind of big bets on websites. When you have millions in the balance, you want to have clear proof that it is. And the second word, unambiguously, is for me the most important thing. If you work for any kind of big company, and by big, I mean anything that has more than 2 employees, you will have fights. If you're in Italy or in France, you will have like actual fights where people yell at each other. I'm sure there's other countries where people are really, really intense like that. If you're in England, they look at each other and think that I won't say anything. It depends on where you are, you're going to fight differently, but you're always going to have disagreements. Disagreements are fine. As long as you're like, we and you, we don't agree on something. We know we don't agree on something, but we can still work together. That's fine. If you have the ability to say one of us is right, one of us is wrong, unambiguously, or you don't have the ability to negotiate around it, that really helps people to move forward. It requires a lot of humility to say, I was wrong, I thought this was going to work, and it actually tanked our data. But that lack of ambiguity is really decisive. There's a whole thing about disagree and commit. A/B test is allowed to say, you don't have to disagree, you can just commit to the right option. You don't have to pile up those things. And in practice, if you work for a large company, that lack of ambiguity is incredibly valuable. Where it is life-saving is in medicine. I can give a lot more examples about medicine. The small problem with them is that at best, they're horribly gruesome and they can get a lot worse than that. So I don't like, if I don't know the audience, I'm not going to share too much detail, but there's a ton of examples of how random control trials or double-blind tests, depending on the details, which is the same idea as A/B testing, have been absolutely transformational. The the test that had the most impact was checking COVID vaccines. You had some really, really superb examples of tests, in this case, that were really convincing. And not everybody liked the idea of having vaccines. So this lack of ambiguity, it should be guaranteed by the process. It's not perfect. We have to admit. Before we go to another section, I'm going to take a break before we go to the code, and I'm going to check with Shada that people are happy. I'm going to check if there's any questions. So Anonymous asked about Renderson's combined effectiveness. Different sets of random groups. I'm not sure I understand the question asked by Anonymous. Someone asked about audio challenges. Is the audio bad? Do you want me to change anything? I've got several microphones, so I can change audio in case this is tricky.
No, but I think what Jeffrey is trying to say is that he has trouble. Yeah, and then
No
we
worries.
should be sharing the recording. Yeah, we can hear you well.
Okay, cool. Happy to hide that. Sorry, Geoffrey, about the lack of audio. Anonymous, I think your question is important. I'm not sure I understand the case. I'm probably going to go back to it at the category. So at the very end, I'm talking about categories. That seems to be a question about that. But if you could find an example or something, I'd love to answer that question in more detail. Does anybody have any more questions that I want to cover?
No questions, I think. Okay, we have.
Could you explain the Z-test and chi-square test and when to use them? Yes, absolutely. I'll go through that actually quite soon for the Z-test. The chi-square, I'm going to talk about the chi-square a bit later. Those are statistical tests. I'm going to the one I'm going to work on now is show you how to run a statistical test. It's not that I'm not a fan. Is most of the time they're very counterintuitive and they have like notation that is a bit difficult to go through. So I can try to explain how they work, but I think it's the goal that I've set to myself this time is to show you an intuition of how statistical tests work in general. I'm using the t-test, but the z-square and the chi-square are roughly the same idea. I'm going to explain the slight differences as we go, but that's the idea. Atul asks, what happens if the external factor goes against the feature method you're trying to promote? That is a very good question. What happens if your test doesn't work the way you intended? You were trying to say less clicks is best, and you remove a couple of clicks to go a customer through a web page, and it doesn't work. Then you're wrong. Then the feature method you're trying to promote might be there might be some assumption that is not wrong. So I use this example of less clicks is good because in general for interaction and design and on websites, less click is better. But there's a point where like you want to ask someone, stop, I'm asking you a question. I need you to pay attention and make sense. If you ask someone, I'm going to take money from you, you want them to understand, oh, I need to agree that you take money from my credit card. Otherwise, they're going to like, this looks dodgy, suspicious. There's like, I feel like there's not enough caution to getting stuff. Same thing for private data. Same thing for, there's a lot of circumstances where fast as not, that's one example of a method that makes sense. There's another possibility is, and that I'm going to go that in the middle section around defining a test property. You might be missing something. Either the users are not who you think they are. So I've got one example I'm going to mention briefly where like we had a website with very international audience and we introduced a new interaction, but the translation was off. So the idea was good, but like people are like, I don't understand what this button does because like the text doesn't make sense because of a translation issue. In that case, it wouldn't work, but your assumption makes sense, but the implementation was problematic. The last example where like your test is going to be negative is if you don't have the right goal. And same thing, I'm going to go through like why goal setting is difficult, and we have some very counterintuitive situations with goal setting. That is probably the most difficult part. If I look at someone who's been doing A/B tests for like 20 years, where I think they spent the last 15 years of experience is not in statistical tests, is in defining the goal properly. You have so many examples of companies that just go in the wrong direction because the goals are just almost there, but the slight difference means that they keep making the not great decision. So that's where you have a theory, like you think that this is going to make customers happier, and they end up not being happy because the goal is not, like, how you measure happiness is not there. That is a very common thing. Please, Sophia, will those notebooks be posted somewhere to access? Yes, I'm actually, if it works, I cannot guarantee because like live demonstration are always tricky. I'm going to share them during the presentation in a way that will make sense. I will ask if you want me to share them publicly, hoping that you will say yes, please, publicly, but we'll see how the interaction goes. So hopefully we'll be able to, they'll be shared afterwards, but I'm trying to share them in the middle of the session so that you can see what it means if you're working with other people and things like that. How are predictive answers validated at first point you can go to an A/B tests? How are different languages models validated? There are 3 models and 3 teams for the same product. There's a whole art and craft of saying, like, you have a change, like for instance, you have a recommendation engine and you have like different models to predict what the customer is going to get, and you have different models that make sense. Some of them is just intuition. If people say your website is too complicated, simplifying stuff works. If people are like, this button, like nobody clicks on it, so there's no point for this button to be like removing, then it makes sense. If you do machine learning system, then a lot of people talk about experiments in machine learning system, and I don't, it's not the wrong word, but they never say it's an offline experiment, as in you have customers who go on your website, they search for stuff, they click on stuff, and you use that past data to train a model. And then you take, you separate training testing sample, and then you look at on the testing sample, you have multiple samples and some of them do better. That is a way to test if your model is good before you try it with an A/B test. But whenever I hear people in machine learning say, oh, I've done experiments, I'm like, no, you've done offline experiments and you need to do online experiments. You need to do A/B tests on your models. So typically, if you do better for offline metrics, for testing metrics, you're probably going to do better on online metrics. There's a connection there, but it's not strict. You have a lot of situations where, like a lot of examples where it's not ideal. One example, which is a bit funny, but I don't think I was planning on mentioning it, but it's a really good example. If you like, oh, people who buy this also buy this, which is a very common algorithm for Amazon. You can try to do it, but then if you start looking at people who, how can I say that, buy certain books and then they buy, I don't want to say shameful, but gender-related products, they don't like the connection. The connection is here, but they don't like when you make it explicit. They don't like if you bought that book about a very romantic subject, then suddenly you like candles and wine and other stuff. That connection is not something people want to have and see that, like, how dare you? They're going to buy it themselves, but they don't like when you make it explicit. So you can have like some weird reactions like that. A/B testing are full of surprises. And so it's hard to predict if offline metric is actually going to translate well to an online metric. So the reason why there's so many people that are specialists of different things, of analytics, of statistical models, of user behavior, cultural understanding, all those have to work together because it's hard to figure out if something is going to work. One number that I'm going to mention many times, it's a big number, but it's very true. You have the best people in the world trying to make the best software in the world, trying to think so hard about how you can improve Google, Facebook, Instagram, Booking. All these websites have a ton of people trying to improve what they're trying to do. And when they A/B test their best ideas, 80% of the time, it doesn't work. We're going to go through like examples where like the stat doesn't work. That is soul crushing. And that is reality telling you not good enough. There's implementation issue, the intuition is not good. And that is the big open secret in A/B testing is most of the time, it's telling you that you're not good enough. And it's not a good, if you carry that message, you're going to realize that's not a good message to carry. And that is why you hear so many people talking about the breakdown to start to go into detail. This is why you have so much pushback against what sounds like an obvious scientific miracle. But yeah, it's most of the time you have to have the humility to be like, I generally thought people would like it. They don't seem to like it. I have to think again. Cool. Please let the Q&A, the questions, I don't know if I can hide the questions for now, so I can focus a bit more on the code. We're going to start doing a little bit of code. Hopefully the beginning is going to be really obvious, and then we're going to do a little bit of manipulation. It's more the attitude towards that manipulation than the actual manipulation itself, because my manipulation is very specific on the file that I just made up. So hope if you have data at home, try to follow with your own data. It's probably not going to be easy, but it's more what I want you to go through is the mindset around it. So hopefully, yes, you can see my screen. This is a notebook. I've pre-typed a lot of stuff because I don't have good memories and I don't want to forget anything meaningful. But imagine I'm typing, because I've seen so many people on YouTube like type the entire demo themselves. I don't know how to do it. I'm generally impressed by the how they can remember all that, but I'm going to try to do it. What I have is a VS Code, which is Integrated Development Environment, or IDE. It has a lot of bells and whistles. One you can see, which is obvious, is it turns the text into multiple colors to tell you what is what, which is really helpful. If you can have an idea with that, it generally helps. The second thing is, if there's a problem, it underlines them in all sorts of shiny colors. So him telling you, I don't know what you mean by import numpy and import pandas, import matplotlib. These are things they don't make sense. Anyone who's done more than 20 seconds of Python is going to be like, isn't that like the obvious? What's the problem? The problem is I don't have the right development environment. So all these error messages is telling me these are external modules and you haven't integrated them. How, if you, so let's just prove that it's just not working. So I have to pick a Python environment, but there's none listed. So the way I can do that is you can use pip to install external libraries. You can use a virtual environment of venv to install libraries, but there's a version of it that combines the two that I really like called Poetry. And if you type Poetry in it, okay, sorry. So that version doesn't work. This was I was afraid of. Let me stop sharing this and use my backup version. So the backup version is a lot less impressive because sorry, I just am trying to. Here we go. Sorry, share screen. This share. Okay. That works. First thing that we're going to do is we're going to read so that's a local file that I've created myself with a simulation. It's stored as a Parquet file. It's not important. It's just convenient because it's convenient. But I've stored it as a data frame, so a pandas data frame. That should be super common for anyone who's trying to look at things. And if you look at what is containing that, you have an event ID, which is a long unique string. You have timestamps. So these are in the future, which should indicate, or most of them in the future, which should indicate it makes sense. And the event type are page views. So you have my favorite website, www.website.com, which has people coming up on the homepage, product A, or the homepage, product B. And they have all sorts of fake information. They come from Facebook, they come from Bing, they come from MailChimp. And they have a ton of interesting characteristic. They use some browser. One thing that is kind of cool is that if you look at the pages, so let's look at one extra at 15, and let's only look at, so this, where am I? Page URL path. So product home, product time, you don't have a lot of example, but if you look at 16 to, let's go to 40. So you see at some point they put into the cart, and at some point they're going to confirm products. So if you look a bit further down, 45. for that. Without a period. So you see here, so one of the users go into cart, then into payment, then into confirmation. So that is your way to tell, okay, that user has gone on a website, on a web page, picked a product, put it into add the cart, fill in the payment information, they receive confirmation that this is. You can have all sorts of source of information, but it's our way of telling that this user has gone through a process and converted. They've bought something. You could have price information or things like that, but that's just a lot more faff than I wanted to deal with. So what you can deal with that database, what I would recommend to do is to always check, okay, so you have all sorts of information. You have the latitude, you have the type of OS, all these you have really interesting. The variant is going to be really interesting. If you look at what the variant is, control and treatment. So these are A/B tested data. And the one that's typically, if you look at it, you're going to notice, okay, this is not what it's supposed to be. Objects in pandas is just a way of saying it can be any value. So it's treated that all the values are text, and there's different possible versions of text. A timestamp is a little different. A timestamp is time. And so if you define a timestamp as type, so you take this column and convert it as type, which is you say that the type is a date time, so it's both the date and the time at the nanosecond level. Then you're going to have the same event where this event is considered a date. Why is that useful? Because if you want to tell how many users there is or how many how active they are, you can take the same data sets. So let's take the same data sets. And say the timestamps, I want to convert them to a period D. D is for day. And so now you have, for every timestamp, you have D. That is less precise than what you had before. But if you say events group by the page URL and the timestamp, that gives you a group by. And so you can use that to count. And that way you have, for every page, so people that reach the cart, people who reach product B, how many of them reach everyone, so how many times you have for each column. So the columns are repeated because they just appear many times, and this is the date that the thing happened. So what you can do is take the events, group by both the page path, which is the page we care about, and the date when it happened, aggregate for user and account, and unstack so that the page level type, rather than be one of the columns, is one of the lines is per column. And so you end up with a daily conversion. So this is just the first few values of daily conversion, but that tells you you have 202 customers who on the first day reach the cart page. You have 95 of them who reach the confirmation page. You have 700 who reach the home page. So it's not really in the right order. And so typically what we want to do in this case is we just want to have everything in the right order. And that means that now we have a page that make more sense. On the first day, so I believe that was yesterday, it's fake data, which is why all the data is in the future. You have 700 people who reached the homepage, 400 who looked at product A, a bit less than 300 who reached product B. So now with a little bit of this group by, aggregate, unstack magic, and ordering the column properly, you end up with a daily conversion table that is a lot more easy to understand and a lot more easy to manipulate. So that is really good, but it's not the result of an A/B test. It's if you want to plot so that people make sense of it. So typically I would cut the first day because it was a partial day, so you only have certain things. And the last day, same thing, they were partial, so the curves look a little bit wonky. But if you come in on any company, you're going to see big screens on the walls, and you're going to see data like that says, here's how many people opened. So this is the number of people. It will be slightly different number for how many times they open, because some people open a page multiple times. So you can rapidly get into all sorts of nuance, but that kind of dashboard is easy, recognizable. And if you've done Libra data, that would be one of the first exercises you do. And hopefully those are examples of how you can make sense. And typically what that really depends on the data and the structure it is. Sometimes the data has different structures. Sometimes you don't have every page. You only have sometimes you have multiple events per page. So it's up to you to decide which one are relevant. I'm going to keep all those for now, but that makes sense. And you can see you have 2.5 months of data. So that's kind of convenient in terms of the quantity of data really makes sense. You have a little bit more effort there. So you typically look at user per variance, and you look at how many of them are unique. So let's just show what this is like. And so that tells you that you have a little less than 21,000, more than 21,000 customers that are, show up in the control and in the treatment variant. So that's kind of useful to know. If you have questions about how many people were part of the test, you can say about 42,000 splits roughly evenly between the two things. And if you have how many conversions you have, you can run this test that says for all the events, you group by, you split variances, treatment versus control, you street page, and look at how many users were in each group. And you have, so this is not super convenient because it's your tables are one after the other, but people who reach the home page, and then people who reach product A or product B, and then the cart, payment, and then the confirmation. So same thing, they're not in order. We want to reuse the order information beforehand, but that starts to tell you, okay, so you have those two functions, count users, count conversions, that splits by variance and by page URL, that tells you for all the people who showed up on your website, how many of them reach every step of the way. So home, because most people come through home, that should be most of them. So that should be at least 95% of them. But confirmation is going to be a lot less. Confirmation is going to be maybe 10-15%. It's a fairly high number. It's a fake data, so I've tried to make it a bit higher to make things easier to see. But yeah, that's not a very high number. Cool. So this conversion rate data, you can then join with the total number of users. So you can take this and this information and turn them into a conversion rate, which is how many users reach a certain point versus how many users reach a total. And so that means that for every, for both control and treatment, for every page you have, here's how many visitors were in that group. So people who showed up on a website in control. So that's always the same because it's the same group of people for all the variants. And among them, how many of them reached that page? So for home, it's 80% because almost everybody arrives in home. Some people start with product A, product B, but most of them come in home. Half of them and a third of them arrive on product A, product B. So you go from home to product. That conversion rate is reasonably high. But then you see it goes down for people adding anything to the cart, people arriving on the payment page, or people actually having a confirmation. The payment to confirmation is reasonably good. You lose 3% out of 18, so that's roughly 20% drop rate. For credit card payment and things like that, that kind of makes sense in terms of drop. And for treatment, you have roughly the same numbers. A bit more than 80% of people arrive on home, half of them on product A, a third or more on product B, and then 25, 18, 17. So those, it's hard to compare as it is. It's not exactly the same group of people. They're roughly 21,000 each, but that gives you a rough idea of what you have. This, you're getting closer to being able to actually run an A/B test because now you're comparing control and treatment. It's just where people reach is you can ask, are there more people who've reached a confirmation page? Control, that's 15.2, and treatment confirmation 15.5. So it looks like there's less people in treatment. That test seems like just on the face of those two numbers, it seems that treatment is not as effective. TBD to do. Most of what you're seeing now is editing the page in a different way. So this, again, you take the table, the conversion rate that we just defined, you pivot it around the page ID and the columns of variance. So you end up with this table, essentially. So you have what's the conversion rate and what's the number of visitors for control and treatment for each one of those. And the good thing is now they're ordered. We've added sort values by the conversion rate. So now they make a little bit more sense. And you can actually use that to draw a funnel. So typically, one thing we could do is you can take this pivoted version. What you're interested in is the conversion rate. and you probably want to plot. So I wouldn't recommend plotting as it is just there, but it gives you a rough idea of 80% home, about half product A, product B, carts, conversion. That is what people call a funnel. The green and the blue are so close that they're almost identical. They're hard to see. I would definitely need to do a lot more work on like having percent rather than 0.8 here. Maybe put the different product A and product B, because like people don't go from A to B, they go to one or the other. So we might want to think about how to represent that on a graph. But those manipulation allow you to go from a raw table to a detailed table where you have all the information. It's not very exciting in terms of statistics yet, but that should be the basic manipulation that, as you can see, the code here is there's lots of functions that we need to know, the index and the column, like getting those functions to work properly requires a little bit of, I could have tried to do it in detail one by one, but it's a bit tedious. But having a version that works and trying yourself until you like understanding what the error messages are, until you get to a version of this pivoted conversion table that is seemingly quite useful, is going to be really, really good. And typically what you want to do now is you probably say, okay, so the difference between this column and this column is probably relevant. I've kept the number of visitors that you're going to see why it's relevant very soon, but that's roughly, it sounds like it's enough to compare which one is best. They seem to have very small effect overall, but that should be enough to compare whether or not it's best. And then you say, okay, so what am I supposed to do? You ask people and people say you should do a t-test. And that's where I think is a lot of the pain point. People tell you that's the most commonly test, and then you read on the literature, and this is copy paste from a website. It tells you that T is the normalized difference between two measures using the expected standard deviation. And now you start having some Greek letters. I feel like, wait, I don't want to have Greek letters. It doesn't make sense to me. I completely understand. That feels tricky. What do all these mean? X is our objective. In the case that we have here is the conversion rate. So these is X. What you want to do if people come on your website is you want as many as possible of them to actually buy something. 15% is a really good number. Typically between 1 and 5%. So 15 is amazing. Your product is great. But what you'd love to have is a higher number. Why you want that number to be high? Because a lot of people who come on your website, either the people who will come on your website anyway, or it's people that you paid advertising for them to come on your website, or you paid social media managers, or you've had a marketing campaign, you've had all sorts of effort to get them on the website. So there's one team that gets people on the website, and there's another team that is once they're on the website trying to convince them your product is great. And that team is trying to explain what the product is, think of promotions, think of arguments like having free shipping, but it's definitely trying to get them to convert. So that team is judged on how high this number is. So that's X. X with a little bar on top is, once again, notation, it's the average over a sample. You don't really think of those as a sample because you've been running the test for a while and it's all your customers, but actually you think of them as a sample for all, it's a period of time, is a sample of your entire activity. So your assumption is that these numbers are going to stay the same as you continue over time, which is not really true, but that's, you make that assumption. And so this is, it's not a sample of all your customers, it's a sample in time over the entire life cycle of your website. That's why you would consider it a sample. And it's like people convert or not, but the conversion rate is an average of whether they convert or not. So it's either 0, they don't convert, or 1, they convert. And the average is 18% for payment, 15% for confirmation. Delta is a difference between control and treatment. So this is X bar, this is X bar, and delta X bar is the difference between those two, if that makes sense. Okay, and now you get into the actual mathematical term, which is S of delta X bar is a standard deviation of that difference, i.e. the commonly observed difference between two independent measurements from the same origin. If you get that explanation, you're smarter than I am. It seems very confusing, but essentially it's saying, if you make that measurement and then you make that measurement again, and you make that measurement again, and you make that measurement again, so presumably if you take this as like a monthly average, you take on January, and then you take the measurement in February, and then you take the measurement in March, you're going to have 3 numbers. They're not going to be exactly the same. They're quite close, but they're probably not going to be exactly the same. And so you end up with a bit of deviation between them. And there is deviation that is considered standard, because if you take those randomly, those are always going to be roughly the same amount apart. And what you do when you have a measurement like the conversion rate or how much people pay to go on your website, any kind of economic activity, any kind of data that you have, if you measure it and you measure it again on slightly different circumstances, measure it again on slightly different circumstances, is going to move a little bit. And that amount of how much it moves is actually this obscure standard deviation. And that is the most important number that we're going to, and when you hear a statistician talk, most of the time they talk about the standard deviation. That is the key thing that is they're trying to address. And so the t-test is simply saying, what matters is not whether 15.2 and 15.05 are different. What matters is how much are they usually different? Is it common to see a 0.2 difference between those? If I take the same measurement the next month, and if I take the same measurement the next month, am I going to see small or large differences? How you get this number S, we're going to talk about soon, but there's an expectation of a little bit of vibration, of a little bit of noise, of a little bit of uncertainty where it is. And what you do is you say, if you have a number for that uncertainty, say it's plus or minus 0.2 every time, you see, okay, there's a difference here between 15% 0.2 and 15% 0.5. So the difference is 0.15% between those two things. You divide that by the, so that's delta x bar. You divide that by the average difference and you have a t. So here my delta x bar between this one and this one is 0.0015 or 0.5%. And if the average difference is 0.002, so 0.2%, then the average is 75%. So this t is going to be 0.75. What happens when you run those, if you look at a random sample and you say, I'm just interested in what's the approximate value, and there's no difference, what you have is typically people are, if you take two samples, they're not meant to be different. The difference between them is going to be about 0. And sometimes the difference is a little bit more, sometimes the difference is a little bit less. So most of the time, they're one standard deviation away from each other. But that is because t is normalized, because 1 means what you should typically expect. But it's not always the case. You have, by accident, sometimes variance that are much higher. And what happens is if this average is over 3 people, you have a lot more noise. You have a lot more chance that out of those 3 people, 3 of them are really outside of the norm. And so you have more chance of seeing 4 standard deviation between them. If the average is between 10 people, you're less likely to have some sort of difference. And if you make really large samples, so thousands of people, then this curve is expected to have very narrow tails. So those values are very close to 0. So it's incredibly unlikely that you're going to be 4 standard deviation away from what you expect. That is the meaning behind this curve. But if you just take that, this is literally a copy paste from a statistical lesson. It is just very difficult to understand. And so this DF, which is degrees of freedom, is actually this number. How many people are part of the average? And so that's why we stored both the difference and how many people are in the sample, because more people in the sample means that you're less likely to have a anomalous timeless test. And what you read in the literature, which seems a bit confusing, is if you consider that there is no difference and you measure a difference, a t that is very large, so t is unusual, so plus or minus 2, we consider this observation to be an outlier. Therefore, we would reject that assumption. The other logic is quite simple. You look at how much money you're making 1 month. You look at how much money you're making the next month. You look at how much money you're making the 3rd month, and you typically made $9,000, $10,000, $11,000. So typically, your average revenue x bar is $10,000. The standard deviation is about $1,000. So if you make $9,000 1 month, it's a low month. So it's -1 standard deviation below average, but it's not terrible. If you make $11,000, it's 1 standard deviation above average, so t = 1, but it's not terrible. But if you make $14,000, then you are 4 standard deviation above average, and that is unusual. If you are comparing your average for the last few months, or a control, which is, let's say, $10,000 that month, versus a treatment, which is $14,000, then the difference between those two, the difference between the average control and the difference between the average of treatment, then is $4,000. If a standard deviation is $1,000, then it is 4 times the standard deviation, so t equals 4. That feels like it is exceptionally unusual. And so you would say this is an outlier. There's too much difference between treatment and control for me to think there's something there. It looks suspicious, there's something you want to know. And so implicit in here is the assumption that you're comparing 2 situations. The difference is between 2 situations that are equivalent. So you make the assumptions that the 2 situations are equivalent, you compare the 2, and if the difference between them is more than you expect, then you say, okay, the assumption I made that the 2 were the same is unrealistic. We have to reject that assumption. And so when you hear significant, this is what you say. You're saying, I expect some noise. I expect things to not be exactly the same. I expect to be somewhere between 9 and 10,000. I mean, between 8 and 12,000 even wouldn't be so unusual. But beyond that, it is so rare and so unusual that I would start to worry what it is. And so this is why you see if t is beyond 2, then this is unusual. That's t which is here. So that's the general idea behind the t test. But I can sense why you're like, yeah, that's a lot of statistics. Okay, it gets worse. Welsh, which is a statistician, look at that and say, okay, because we're controlling control and treatments, what we can do is consider that both control and treatment have reason to be uncertain. And therefore, the standard deviation between the difference between them is actually supposed to be expressed this way. There's square roots for reasons that I won't get into too much detail. And because of how things work, when you look at conversion rates, so that's a conversion rate, the standard, the variance for one instance is this. And when you pile up multiple instances, if you look at what is the variance of 10,000 people coming on the website, then the standard here is multiplied by the how many times you make an observation, but because it's the average is divided by the how many people you have, you end up with this formula that says that you look at so that's the delta between the 2 values, and the standard deviation is this big mathematical formula. If you are very unconvinced, honestly, that's the simplest explanation I could find online for why this is the way it is. It makes a ton of sense if you go through the equations one by one, but your stakeholders will not care. They will see a very complicated equation. They will see a t value that doesn't make sense for them because they haven't gone through that intuition, and they won't like that. They're not able to challenge what you're trying to show. And that is the key lesson here. I'm not intentionally trying to make it confusing. I tried to make it as understandable as I could, but it must have been confusing for everybody. And I'm really sorry about it. I just want you to get the impression like this is not an easy thing to grasp for people. But essentially, you end up with this formula that says, if you want to measure the t for a certain event, you take the difference between control and treatment to value, and then you take this big equation. And it's not super difficult to process. Basically, the difference between the two is the conversion rate between control and treatment. So that is this top part. The standard deviation, so that is this one, is the conversion rate of treatment multiplied by 1 minus the conversion rate of treatment. So that whole thing is the top part here, divided by the number of visitors for treatment. So that's this number of visitors, t. The conversion rate for control is the same thing, conversion rate multiplied by 1 minus conversion rate, and then divided by number of treatment for visitors. So this big standard dev is this whole thing. And so the t-score is that difference that we just computed here, and the standard deviation that we just computed here. So now you have this t-score. If you have a table like, let me go back up, like this one, with the conversion rate for control and treatment, visitors per control per treatment, you can define a difference, a standard deviation, and a t-score. So that's what this compute test is doing. The degrees of freedom is how many control and visitors you have, -1 for reasons. And then you take the p-value. The p-value is the most important aspect of this computation, but it's a bit counterintuitive. So let me walk you through what p-value actually is. If you have a t-score of 0, it means there's no significant difference. 1, 2, 3, 4 are more unusual. But depending on whether or not you have a small degree of freedom, or if you use other distribution than this one, so if you look at other phenomena, so that's the chi-square and the z-score. So z is the same, z is the top line for this one. Z is when t is maximal. A t of 2.5 can be rare, or tier 3 here if you take. A tier 3 is rare for one case, but it's less rare if you have a small degree of freedom. A tier 4 is incredibly rare if you have thousands of visitors. But if you have a handful of visitors, a tier 4 is not so unusual. So T itself is an intuitive version of how unusual it is. But if you have small samples, a high T is not an unusual thing. So you want to normalize that. The way you normalize that is, see, I want to know how close you are to the end of the tail. So a T of infinite amount is going to be a P of 0. And then anyone who's really far out is going to have whichever P is left. So it's 1, 2, 3, and you get the P is increasing in amount. And a P of 1 is there's absolutely no difference. And it's the same thing symmetrically. So if you're really far off here, it's a very small amount. So it's a 0 or 0.001. And then it's a bit more, and then it's a little bit more. And around here, it would typically be considered 5%, because you have 5% of people of the surface of that tail that is in that end, or 5% that is in that end. So you 0.5. So you have a P of 0.05 means you are in that area of the tail. Or if it's less than that, you're further out than that. So P is a metric that is the same idea as T, but T of 0 is not any difference. And the bigger the T, the more unusual. P is the opposite. A P of 0 is incredibly unusual. It's the massive outlier. And a P of 1 is you're in the middle. But the T goes positive and negative. P stays between 0 and 1. So this is 0, this is 0. This is a small number, typically 0.0 something. This is 0.05. These are a P of 3, P of 0.3, P of 0.4, and this is P of 1. So P is where you are on that curve, how much of an outlier you are responding to that curve. The way you compute it is you take the T, so that's statistical distribution, and you apply the T-score and the degrees of freedom to the p-value to get the distribution. That's the idea. The last thing that you want to say is you have to set, when you run a test like that, a significance threshold. If you go back, sorry, I don't know, So when you say, we consider that difference significant, you have to set, what is an outlier? We said around 2. So you can set that difference as a threshold in T. So you can say, if a T is more than 2 or less than -2, it's beyond that, then it is an outlier. But that is not standardized, because T is not standardized. If you have a small sample, T is not the same as if you have big samples. It's not the same meaning. But for P, it's standardized. A P of 0 is always the most unusual outlier, and a P of 1 is always no difference. So you can set the significance threshold in P. And the standard thing people will do is they say the most extreme observations, so the smallest value of P, that are less than 0.05, so less than 5%, we would consider outlier. But you have to set a threshold, because that curve is doesn't really have a clear marker delineation, or we in, we out. It's not a box with a vertical line, it's a slope. And so typically, if you look at 0.025, so 2.5%, that's this section of the curve. And you have 2.5% in this section of the curve. So the two together make a 5% extreme tails. That's the idea behind this 5% confidence interval. But that means that the 5% is, if you compare sales from one month to the next, and you look at the difference, usually the difference is not big. Usually the difference is in this main area, but sometimes it is beyond that. And actually, you know how often it is beyond that threshold, because that's the sense, that's the meaning for that 5% threshold. So if you look at, is June and May the same? Is May and April the same? Is September and October the same? If you do that 10 times, 100 times, 1,000 times, 5% of the time, you're going to be like, oh, wow, there's a big difference here. I wasn't expecting that difference, because you've done nothing to your website yet. There's no meaningful changes. That is the idea behind the 5% significant. It's not, if you do nothing, you should see that difference 5% of the time. If you're comparing two things that are meant to be identical, it should appear 5% of the time. That's what the 5% means. And this is very counterintuitive, because you're never doing nothing. And that's why this 5% is just rubs people the wrong way, because it only makes sense if you make an assumption that is absurd, which is you're not changing anything. So because you set this threshold at the P has to be less than 0.05. Therefore, if you take the Z-score, or the T with a degree of freedom, which is infinite, because there's roughly the same thing, then the T is beyond, so it's not exactly 2, it's 1.96, so it's almost 2. But because you know what is the standard deviation, rather than say T is beyond 2 or T is beyond -2, you can say the difference is beyond 2 multiplied by the standard deviation. And so rather than say, I want 2 units or 3 standard deviation less than usual, which doesn't make sense for anyone who's not a practitioner, you can say, well, the standard deviation for my monthly revenue is $10,000. So anything that is $20,000, so a T of 2 multiplied by standard deviation of $10,000, so $20,000, anything that is more than $10,000 in more or in less than usual, I would consider unusual. And so if you see a difference of that much, you can detect it. You can be like, that is unusual. That I was not expecting that. That is what we call the minimal detectable effect. And so getting there is a little bit counterintuitive, but it is the easiest way to explain to people what your test is trying to do. If you say, okay, I'm going to test something and I'm going to compare changes in revenue, because a revenue every month is 9, 10, 11, half past 10 and a half, 9 and a half, 8. It's just roughly around $10,000. But sometimes it's higher, sometimes it's lower. Seeing a small difference of only $1,000 is typical. So you're not going to be able to see it's unusual. But if it's a difference of more than $2,000, so if suddenly the website starts making 7,000 rather than 10,000, so that's a difference of 3,000, that's 3 standard deviation, that is a big difference, then I would consider that, because the difference is more than a minimal detectable effect. That works presumably both ways. And that's, okay, we think the difference is significant, is if the p-value is less than a threshold alpha that we've set at 5%. That is just the intuition. So if you want to have exact values, so T is plus or minus 1.96234 for a D of 5% both ways. You have this debate between, do you consider only 1 tail or 2 tail? That is more or less creative. If you only look one way, it's 1.6. So you'll hear 2 as a rounding of this value, or 1.6 as the 2 common values, because 5% is the most commonly applied things. So we have this result value that we've had, and we have the conversion rates. So this section you should be familiar with, and we've discussed. So the difference here is control. There's a treatment minus control, so you have a little bit more conversion there. So it's a small difference here. The standard deviation, so we've calculated that with an abstract formula. So this abstract formula. The t-score is the ratio between the two. So here the difference is very small, the standard deviation isn't big, but the difference between the two means that you barely have any kind of difference. Same thing for product A, you don't really see any kind of meaningful difference. Same thing for product B, same thing for product C. Same thing for payments. You don't really see any kind of meaningful difference, but this time the payment's lower. You have the t-score here is 0.4, that is a little bit more, but still it's really, really small. And the degrees of freedom is how many people were in both samples. That's why it matters. And the p-value, so if the p-value is very small, you are at the tail end. Because here, none of the differences are meaningful, the p-value is reasonably high. It's always around the middle, so none of that. The smallest p-value is here. You have like a difference of half a standard deviation, so that's not really unusual, and that makes sense. And here you have this minimal detectable effect. So what would be the amount that we would be able to see? Yeah, that difference is something where we think it's significant. But in no case does the difference bigger than the minimal detectable effect. So all of those are considered not significant. One thing that you want to notice when you look at the formula, the one important lesson is that the standard deviation is smaller if you have a large number of participants. That is because the average height of a large group is more regular than the average height of a small group. You average out with more people, you're just closer to the you have less volatility. Therefore, if the S is smaller, then the T is bigger. So if you have a large group, and if that group is made of people who are unusually high, because it's a larger group, you have an easier time of detecting that the difference. The T is bigger. You also have an effect on the shape of the curve, but that's not as important. So essentially, when you run an A/B test and you have the result that you have here, which is we run the test for 2 months, we're not seeing any meaningful difference between the control and treatment. One thing that you will hear a lot is, could we test for longer? The reason for testing for longer is presumably because if you test for longer, you're going to have more people coming in a website. So you might not increase the treatment or the difference. You're probably going to increase the number of visitors for treatment and control, which means you're going to lower the standard deviation. The difference could be roughly the same. Well, those are really small differences, so I hope this is not the case. But let's say you have slightly bigger differences. The standard deviation is going to be smaller, and therefore the t-score is going to be higher. And hopefully, if you get a higher t-score, you're going to get a smaller p-value. And if you get a smaller p-value, you're going to get a significant result. So you're going to be able to say, actually, that difference between the product A and product B, well, all of them are kind of bad, but the increase to count, so the fact that this number is bigger than this number, it looks kind of big. If you are the responsible for the conversion rate and you see, well, it's usually 25.6 and here's 25.7, I feel like 25.7 is more. If you test for longer, you're hoping that the difference is going to stay there if you test for longer, but the number of visitors being higher, the t-score is going to get higher, and therefore the result test is going to be significant. That's when people say test for longer, what they actually mean is test on a larger sample of people, test on more people in order to get higher. Which is, so I could try to get a larger sample, but I don't have a larger sample. That's all I created. If you look at the original source, we have 31 columns. We have 132,000 events over the course. What happens if we run the test? So that's just a summary of all the tests we've run, but not on the entire events, but just on the first 10,000. So we can run the test, and you have, so the conversion rate is a little bit smaller, but product A is a little bit less. So those numbers are roughly what we expected, but we have only 2,000 visits in control and treatment. So you have a smaller sample. The difference are just as small as before. The standard deviation is bigger. And the t-scores, because you have a small sample, wait. Oh, no, that's actually a big difference. So you went from 78% conversion to 74% conversion. So that is actually a big difference, that difference of 3.5% here. If you compare that to the standard deviation of 0.13, which 0.013, that is unusual to have such a big difference in standard deviation. But that one, then the t-score. So you have significantly less people who reach the first stage in treatment in that sample, or the first 10,000 sample. There could be any sorts of reason why, but you can see why running on a small test gives you higher standard deviation. It should give you lower t-score, not in this case because the sample is a bit unusual. But that is why people typically don't want to run on small, they tell you to run on small samples. P-value, That's the sample for the p-value. So that is the default explanation for how A/B tests work, and it comes with one really obvious issue. That is that most of the time, people have worked tirelessly to build a very exciting change, and you come back and say, I can see a small difference between the two, but it's not significant, and therefore we have to reject the assumption. If people have worked on something for months and you tell them the difference is not large enough for us to it's not really significant, they're going to push back. They're going to look for anything that they're not happy with, not something that is inherently wrong, something that they're not comfortable with, and they're going to push back against that. And if the best explanation you have for why what you're doing makes sense is a bunch of math like this one, you're not going to get a lot of adhesion. People are going to be like, I don't understand this, and they're going to go after you. And that is not a very helpful interaction to be with. That's why when you run an A/B test like this one, what you want to do is you want to make sure that people understand the point that you're trying to make. And the best time to make that point is to make that point before you run a test. We're going to run an A/B test. Before we run an A/B test, let me walk you through how they work and why I think they're valuable. And once they understand the principle, they're going to know, okay, if my test is non-significant, then I know it actually means that there's a problem with my idea. It's not that the test itself is problematic, it's the idea is not good. And therefore, I need to challenge my own assumptions. I need to rethink, okay, is there a problem with the idea I have? So that I can understand the impact I had wasn't what I wanted to have, but that humility doesn't come for free. Let me stop here, see if there's any kind of questions, and we can switch to what to do to talk to people who have go through this very painful moment of not knowing why the test wasn't as good as they wanted to be. Any key questions in the Q&A? Anything new? Can the book be shared with participants? Yes, it will be shared, hopefully either after the presentation or during the presentation if I can figure out. Maximize the PowerPoint slide so we can clearly see the code using the presentation. I don't think I can make anything bigger, but if you think this is too small, let me know again in the chat. But I'm hoping that this is large enough for everybody to see. If not, let me know. Are there consideration on data before diving into different variants? So the variance, control and treatment is, I'm going to go through like how you run that, but the idea is make sure that the two are as equivalent as possible. One thing that I won't touch, and it's the biggest nightmare when you run A/B testing, so I should probably have mentioned that, is most websites have an astounding amount of bot traffic. It used to be half. I think now it's like 2/3 of the traffic, more than that sometimes. It depends a bit on the website. So Facebook, you have to be logged in. So a lot of there's not bots inside. There's lots of bots that are trying to log in, but usually, hopefully they don't manage to get in. Some do, but usually they don't manage to log into anyone's account. So you don't, on the account, once you're logged in, you don't have that much. But search engine, websites, any kind of public forum, you have like a spectacular amount of bot traffic. E-commerce, there's a ton of bot traffic until you say you ask for payment, and then suddenly you have a lot less bot traffic. And the idea is, before you say you are part of treatment, you're part of control, you're part of treatment, you wouldn't need to get rid of that staggering amount of bot traffic. Why do a t-test? What is it for? A t-test is here to say, is the difference I'm seeing between those two things unusual? Essentially is, I'm seeing a difference. Is that difference not a difference, or is that difference suspicious? And if the difference is suspicious, is it so anomalous that I want to consider it a difference? I tried to give an explanation for that with the statistics. It's very hard to explain it with statistics to people who are not familiar with higher level of abstractions. I haven't gone through the abstractions because I feel like that's part of master's in statistics kind of program. Hopefully my next explanation, so I'm going to talk a bit about product and then I'm going to go through an AA test. Hopefully the AA test makes a lot more sense. Is the TF based on the sample size? So I've created a synthetic e-commerce activity trace that is just randomized. Like I've got a library that creates things. Degrees of freedom, not data frame. Yes, the degrees of freedom is the how many in that case is how many participants minus one. The minus one is a way out of fact, but it's if you have 1,000, that doesn't make a difference. How long should you run an A/B test for? So hopefully that's a question I've tried to answer, but not very successfully until now. If you run an A/B test, you are able to say, here's the minimal detectable effect for a conversion rate of 5%. You can just run the same formula I've run and say, so I won't be able to detect a difference for more than 1%. So if someone shows up and says, I think this is an improvement, but I don't think it's going to increase the conversion rate by more than 1%, you can say, okay, if you run it with 20,000 customers, I'm going to be able to detect a difference of 1%. And we have 5,000 new customers every week. So if you run it for 4 weeks, we should have enough customers that we should be able to have a minimal detectable effect that is less than what you're trying to, the impact you're going to have. So there is a classic way of using the math I just showed you to say, to go from how much audience you have, how many people after how many weeks, and therefore how much is of an effect you can detect, how small an effect you can detect. The longer, the smaller the effect you can detect. That math relies on the fact that your traffic remains constant, which is never true. The fact that the people you're talking to actually are able to estimate how much of an impact the change has. The reason to know an A/B test is to measure that impact. And people ask you to know an A/B test because they don't know how much impact. So if you ask, if to say, I don't know the impact, can you run an A/B test to tell me? And say, what is the impact? That's a very frustrating conversation for everybody. So my recommendation is to show them examples for here's how long it would take me to detect 0.5%, 1%, 2% difference. Ask them how much you think you're going to detect. Take notes in front of them so that they know that you have what they said before the test. Run the test and then show them. Last time you promised that you're going to have a 2% difference. You had less than that. Then you promised a 1% difference. You had less than that. Like you tell them every time you make an estimation, you are overestimating how much of an impact your change makes. You're not good. That feedback is really valuable because it lets people be a bit more humble and be like, okay, so if I run the test for 6 weeks, I'm going to have that much impact. I can detect that much impact. I'm expecting that much, but usually I'm wrong about how big the impact is. So I probably should wait for the test for a little bit longer to detect a bit less so that I don't have a test that tells me your change had no significant impact. We've measured the difference, but that difference was not significant. Recording. Yes, on the smaller sample. So I took a sample of 130,000 observations, and I look at the first 10,000. On the first 10,000, you measured a bigger difference. That happens quite a lot. So that's like when I say smaller samples have more noise. That's one of the reasons. And so there was more of a difference, and those appeared significant. But as you noticed, they probably were fake. They were just that small difference prove if you run it when you run the experiment for longer to not be significant. That is quite common, which is why when people say, oh, how long, like, what is the precision of your test? Are you going to run a test for 6 weeks or 8 weeks? People will suddenly like 6 weeks, 8 weeks, that's way too long. Can I look at the test after 4 weeks? And you can make it run for 6 weeks or 8 weeks. What happens when you do that? That is called peaking. So as in looking behind the window, peaking. Once you do that is you end up with having, every time you look, you have this 5% chance. If what you're doing is not effective, if your change is not really good, you have a 5% chance of seeing something that is not there. If what you're doing is negative or is effective, every time you have like this small chance of it being not there. So if you say, okay, your test needs 8 weeks of running, and people are like, can I look at it? And they look at it on Wednesday, and they look at it on Friday, and they look at it on Monday, and they look at it every 3-4 days while you run it for 8 weeks. They look at it 24 times. Imagine you have a dice of 1 out of 20 and you roll it 25 times. How many times did you hit a 1? Like you end up seeing, oh, now there's a significant effect. That is a really big problem of looking too many times and peaking. And so that's why when you say, okay, we don't have a lot of customers, your change is not going to have a big impact. We need to run a test for 6 weeks or 8 weeks. There is a reason to tell people don't look at it too early, because otherwise you're going to see things that is not there. There's a counter argument around if there's a genuine problem, if your test is like hurting customers. You want to interrupt early, but that I will go through that difference a bit later. But that's the typically people, what they want to do is they want to look early so that they can say, I had a really good impact, and they get a promotion. So that's why it's tricky. What other things apart from website can be used for? Pharma, manufacturing, absolutely. Anytime you are A, making a change, B, measuring something, and you're wondering if the change impacts what you're measuring. So pharmaceutical is you do not use tests. You use tests for everything. Every drug, for humans or for animals, is always tested with like a similar process. So in pharmacy, they call it a random control trial. Because software engineers like shiny images, they call it an A/B test, but it's essentially the same thing. In medicine, you have, because humans like having drugs, just not effective one, any drugs, because of placebo effect. If you tell someone, I'm giving you a drug, it's going to be effective. So what you do is you tell someone, I'm giving you a drug, if you don't give them actual drug. And so in that case, the patient doesn't know whether they're in control treatment. So they're blind to whether they're in control treatment. But what they're worried is if the doctor knows if the patient is in control treatment, the doctor is going to behave differently. So the doctor themselves don't know if they're in control treatment. There's a third person who knows who's in control treatment, and they don't tell the patients and they don't tell the doctor. And that is called a double blind. But that's just specific to humans because of how it works. You cannot do double blinds on a website because, well, if I add an Apple Pay button, people notice immediately. Manufacturing, yes, it's done quite systematically in manufacturing. Like if you change a process, if you add someone, what you would do is you'd be like, do you have more error rates if you have an automated system, or if you have a new machine that is more expensive, or if you pay 2 people rather than 1 people? There's a ton of changes in manufacturing that make sense to make sense. Share the code and the data source. Yes, I will share. So the data source is a really big file, so it's a little tricky, but I'm going to share. What is control and treatment? So control and treatment, let me re-explain again, because that's really cool idea. You have a service, a website, patients that are dying or not, or you have a workshop that is working, and you say, I want to change something. Rather than change for everybody, you pick all the interactions. So for a factory, it can be days of the week. For in a hospital, it can be when you're giving a drug to people, it's like you split the patient between 2 groups. If you're on a website, when people arrive on the website, when they arrive on the website, you flip a coin and you're like, heads or tails, people are in control treatment. And it's 2 groups of people. The important thing is you need to have units that don't talk to each other, they're like separate, that don't. And so if I look on a website and you look on the same website, we actually don't see the same thing. If it's a social media, because we comment, there's a bit of a difference. So if I am allowed to post photos on Facebook, but you're not allowed to post photos on Facebook, and you see my photos, you're like, how did you do that? So on social media, it's a bit more complicated. But generally on like search engine or e-commerce website, if I get a promotion, you don't get a promotion. Or on supermarkets, if I get 10% discount on my next grocery shopping, like I won't probably tell you, so that won't be a big difference. So you have to have units that are autonomous, that don't to each other. You split them into 2 groups. The 2 groups have to be as close as possible. And the nomenclature, the tradition is control is people when nothing changes. Treatment is something new. So they get a special drug, they get a promotion that you haven't had before, they get a new version of the website with like an extra new interaction, and they have a new feature. But it can be like, you can reverse the roles. It's not like it's just you have 2 groups and you're comparing 2 groups. It's easier to give names to both groups so that it makes a bit more sense. But typically control is what we had before. Treatment is a small change. And so control and treatment is both the 2 groups, so the 2 units, the 2 individuals. It can be sessions. Like if you go on Google, you search for Google, and then you come back an hour later, you search again on Google. You can be 2 different sessions because presumably you are not searching for the same thing. So what you found the first time won't influence what you find the second time because you're looking for different things. So a unit can be quite different. You take all the units, you split them into 2 groups, and one group has a different treatment than the other. They see something slightly different. You also give the name control and treatment to the measurements that's coming out of that. So you can say there's a 20% for control and 21% for treatment. That's also quite easy. So that's the examples. If the test controls for sample size, how does this sample size give different conclusions? I'm not sure I understand that question. So what you might be saying is, if when people come, they are assigned randomly to control treatment, why are the two populations slightly different? Because it's random. Like if you have a very large sample, the two numbers are going to be close, but they're never going to be exactly the same number. That's just how randomness works. You can force people to have exactly the same number. So yeah, rather than use randomness, some people say, whenever someone comes, I'm going to give them in one group, and the next people coming, I'm going to the other group. So it's odds and even people are sorted into groups. There's some specific reason why this isn't great. It's like mathematically not super trivial. So randomness works better to have two groups of equivalent people. But you will never have exactly the same number of people. And the small differences you see here are not necessarily a big problem. I'm going to talk about separation mismatch a bit later. It's not necessarily a problem in itself, but it can betray another problem. So it's a very common thing to check, but they're not exactly the same size. But if you run a test for a short amount of time, you have fewer people. If you run a test for a long amount of time, you have more people. So you have tests where you have a small sample size, you have tests where you have a large sample size, but that's because two tests are quite different. What is the minimum sample size for performing an A/B test? That's a good question. It depends on how big of an impact you have. If you're trying a big transformation and you expect like people to completely rethink what you're trying to do, so you trying to sell music online and you sell music by like 10 cents for every track, and then you're trying to sell albums, but it's not really working, and then you're like, okay, I'm going to do like Spotify $20 a month. That is a completely different. And so for that big change, you would definitely expect people to have a very different conversion rate. You could try a small sample for that, but it's very rare. Most of the time, what you're trying to do is a marginal change. You're making like, rather than have 10 results on Google, you put 15 or you put 8. So like, it's not super visible. You're trying to have, rather than have to click on the card and then the payment page and then confirmation, you click and you're directly on the payment page. So it's not going to like move the needle by more than 1 or 2%. If you have 10,000 of people coming in a website, 5% of them reach, or 10% of them reach the conversion page, then you have like hundreds of people saying that. And then you're going to have a small difference of 1 or 2% on that. That's not going to work. The numbers I've heard the most is it makes sense to run A/B test on pages that have 20, 50,000 visitors. That is like the rough idea. So if like you have, that's per week, you can run a test like a couple of weeks and it makes sense. If you have less than that, then you can run a test over several months. If you have more than that, then you can run that on like pages that have less traffic. So it's very subjective, but it's still quite tricky. I think if you have less than 300,000 visitors, there's going to be a situation where it's not great. Like pages that are less popular, if what you're trying to test isn't really effective. If you start having more visitors than that, then yes, then you can A/B test more systematically. But I would recommend, even if you don't have a ton of power, it makes sense just to get started, show people how it works, show them like if you change how it was a bit more ambitious, then it makes sense. But like you were still struggling. And get the code, get the habits running so that people are used to it, and get people used to you saying, look, what you tried to do wasn't as effective as you would like. Because if you like, your change had a 1% impact, anything less than 2% we would not have been able to detect, they're going to be a bit angry, but that's going to get them in the mood of like trying something a bit more ambitious. That's going to be less, you'd rather start there than going to like, your change was 3%, and like this is the first time running A/B test and it doesn't really like, it makes sense. Try early, even if you don't have enough audience, just to get people used to the idea. You don't have to use it to make key decisions if it's still very early and you're not entirely sure how the system works. But get people used to the idea that you're saying it's not really great. So what we've talked about so far is this whole data wrangling. The example I've showed is purposely simple. The total visits and the period of the experiments that wrangling is reasonably easy. But if you actually have multiple experiments running, you have to isolate experiments for the start and at the end. You have to decide which users to expose. So if you have bots or suspected bots, it's a lot more complicated. And I would recommend to have experiments who overlap, because that way, if you have, let's say, 200,000 visitors per month, you can run an experiment on all these visitors, and you can run another experiment on also all these visitors, like the two experiments are independent. So that allows you to experiment more, but it makes your data wrangling a bit more complicated. But the reality, as I've really tried to mention as much as I can, because a few things prepare you to how much austerity that means, is basically most of the time, and when I say most of the time, 80% of the time, someone comes up with a really good idea that try, and you say it's not significant or it's negative. And that is about as welcome as telling people that the baby is ugly. I don't know if you've tried, don't. Well, tell people the baby is ugly. Tell someone the test is not significant. I mean, you're in this workshop, so you're probably going to have to do that at one point. It's not great. And that's where the expression that we hear the most when people do experiments, which is hypo for highest paid person's opinion, comes in. One of the most influential people who do A/B testing is someone called Ronnie Kohavi, and he works a lot at Amazon. And he's got some really exciting stories about him telling that Jeff Bezos, the CEO of Amazon, all the ideas about like doing rebates and doing this and doing free, like when nowhere near as effective on the customers as he would like. I don't know if you've met Jeff Bezos. He's loud. He's got strong feelings. If you tell Jeff Bezos that his baby is ugly, you're going to really, really hope that he says what he means when he says trust the data. My understanding is in the end he did, but you're probably not going to show results to Jeff Bezos because he's officially retired now, but your CEOs may or may not be as nice, may or may not say trust the data, may or may not mean it, but you're going to show a lot of results to a lot of people, and there's going to be a lot of people who are, I mean, I've been physically punched because of test results. Like that's not a joke. Like you will get hated for it. But if you're big and strong and you don't care that people punch you, which is my case, or if you're agile and can avoid people, or if your colleagues are not violent assholes who punch you, you will just get into a heated argument, which is not great. But important people will tell you that they don't know why you're wrong, they don't care about statistics, and they hate you. And that is like, you have to be ready for it. You have to be like, look, there's some issues, like let's explore what may be the possibility, but never exclude the fact that the idea wasn't what it was supposed to be. Another very common thing is if the result is non-significant, people will say, oh, it doesn't have an impact. No, it does. Like a lot of the time you can measure an actual difference. You're not sure if that difference is well measured, so it might be not the exact measurement you have, but you're never sure that it is zero. You assume it's zero and you prove it's not the case. You have this weird philosophical back and forth. But don't tell people who say, oh, the result is neutral, therefore we can go forward. It is possible that your test is underpowered. If you run it like this experiment starts and for a few days is going to be non-significant. So that's just tell people how much power you need for the experiment. Then you can say, I don't know if it's zero, but I can tell you that the result is, if it were more than 1%, we would have detected it. We haven't detected anything. So we know that it's a small impact. It's not neutral, it's small. That it's not neutral, it's small. It's a good thing to have. Make sure that your experiment is powered enough so that you can actually have this argument that it is small. Sometimes you do an A/B test not because you want to measure something, but because you want to improve that number, but because you will have other reasons to do it. The very common one is you're trying to remove some code and you're not sure that two versions are equivalent. So we like to remove some like weird options in the memory that no one ever uses, or you refactor the code. So there was a website, it was working, but it was just very confusing spaghetti code that everybody hated. People turning into a website that is presumably doing the same thing, but the code is a lot easier to manage. So people want that to go forward. And they do an A/B test, not because they want the number to go higher, but because they want the number to not go down. They want to make sure that like it doesn't hurt the business. In this case, neutral, which is non-significant. Like it makes sense to do it that way. There's a slightly different test where like you assume that it's not neutral. Like you have ways of handling it, which is very rarely done. But that's just be sure to understand the difference between significantly positive, significantly negative, non-significant, and none of those being neutral. The opposite problem you might have is you run a test and it actually really fucking works. But there was like an entire redesign. There was like 3 or 4 things changing. And like what is going to happen every time is that everyone who has their own champion, and like maybe you made the images bigger, but there's less images, and like the images like dynamically resized because it wouldn't work on mobile. And so you have 5 or 6 changes in one single test. Then the engineer who worked on like resizing images and the engineer who worked on like getting more people to actually upload high definition images and the engineer who worked on like getting the mobile website to work, all those are going to say it's my fault. And then you end up with a situation where victory has many fathers. It's not that big of a problem to have many people very proud of how much they saved the company. If you work in a tech company, you're going to have a lot of people who keep telling you that they've saved the company many times over. But it can add up into people who actually, if the change had no impact, was merged with change that has any kind of impact, they think that they are wonderful. but the actually change is not that impactful. And that can be really problematic because they're convinced of something that is not true. That is going to be a problem later. They're going to be like, I did that 3 times, and every time the test was really good, but I missed the fact that it was something else in that test that makes sense. So my recommendation is try ideas that are reasonably ambitious and try ideas that are atomic. So change something that is meaningful. But if you need multiple things to change at the same time, test those separately if you can. So large, but atomic. Atomic as in single unit, like a minimal amount of change possible. If you have plans to like improve and fix problems and make those tests just afterwards, or run those tests at the same time, add those so that you can have significant results. You don't have to run this test necessarily for a long amount of time, but if you can say things like, look, this change is necessary because otherwise for a small subset of users, the situation will be unmanageable, but that's not problematic. One other thing that is super common is users have a very varied. People who work for the company are less varied. So I worked for a fashion company, and you had everybody who worked for the company knew everything about fashion. That's why there was a brief that you could, every time they came in, you had to comment on the dress. It was a whole thing. They were convinced, for good reasons, that our users were the same. Whenever we had like, oh, we have like tickets for Fashion Week, or we have tickets for a new collection, you would have hundreds of people showing up. But we didn't have hundreds of customers. We had hundreds of thousands of customers. And we kind of missed that a small minority of our customers were really engaged, but the vast majority of the customers couldn't care less about fashion. Well, a little bit. They just wanted rebates on luxury products, but they didn't care who made that product. So a 45-minute documentary on the life and work of Miu Miu, which everybody in the company thought was wonderful, and it was an idea that they pushed really hard, tanked when we A/B tested it because it was, the video was between someone and them buying shoes, and they couldn't care who, like the 45-minute video was just not really helping. That your idea is good, but it is good for a small subset of customers. Therefore, on the overall company, it just doesn't make sense. Is a very, very common problem when you're running A/B tests. So it's not that like the baby's ugly, is that the baby is one baby among many babies, and that's just no one cares about the baby. Sometimes what you're trying to do is fix a very specific problem. So if you're trying to fix something with customer service, don't test on the entire website. Test on people who call customer service, which is going to be a small subset, hopefully, and see if for those people it make things better. And people who don't call customer service don't care, so exclude them from experiment. So that is like exclusion criteria are super important in that context. Same thing, if you're trying to add pixels on a website, bigger pixels mean more conversion rate. So if you want people to click on a button, make that button bigger. But it also means that they're not going to click on something else. So make sure that you set things properly. So that's the general idea when you have like some bad change that makes sense. What does that mean? So the first thing that is going to be super difficult to get people to stop reacting like you're insulting the baby is loudly say before the first test, months before, weeks before, if you have a meeting where you have the first test, that's going to be really important. Say, anytime someone is surprised, disappointed, angry, this is good because we are learning. I've done so many tests where people were like, I thought that was a good idea, but if like the measured impact is like it's tanking conversion rate, it would have cost the company hundreds of millions, dozens of millions. I have seen that so many times. And every single time you had very senior executive who was like, are you telling me my baby is going to cost the company 2% of the revenue? Like, they are shocked. My reaction every time was celebratory. If you can afford it, cake, sparkling Roman candles. And like people are like, what the fuck? You're just telling me that the idea cost us millions in development and we have cost the company hundreds of millions. Like yes, because today we save the company hundreds of millions because we're not going to release that. I mean, unless you want to take that. Sometimes it's a terrible idea. People still release it, but say we learned something. Big surprise, big disappointment. People shocked at the results. We've learned something. I don't know yet what we've learned, but I know we've learned something. Sometimes it's a very simple mistake. So I remember releasing a new, selling something online, and we had a cancellation button like while we were processing the payment, and that button was mistranslated. And in a lot of countries where you have like credit card rather than a debit card, like this interaction didn't make sense. So just the whole thing was very confusing. And that test was obviously a good idea. It would have cost us a little bit of money on like cancelling fees and things like that. So like people were not super keen on it, but it was really tanking. And we didn't know when we saw a result, we didn't know what happened. Still, we had a celebration because we're like, whatever that was, we know there was a problem. The problem was twofold. First one is the whole interaction process was really unfamiliar with. We had a lot of customers in China. The website in China very different. We didn't know that. So that was used, and like a couple more, to say we need to have a software team that works exclusively for the Chinese market. It was a big, difficult decision, but we could prove it was worthwhile. Second thing is we use red for the cancellation button, which kind of makes sense because you had to tell people that don't click on it unless you really have to. Red is not the right color for Chinese people. So same thing that we learned culturally. We really needed people to know what was happening. But more importantly, we learned that the translation service we're using was crap, like generally terrible. Like there was multiple languages where they got the language wrong for excusable reasons. We wanted to translate to Indonesian and they translated to Malay. Both of them are called Bahasa because it's the word for language in Southeast Asia. But like that's not the same language. Like it was understandable, but like it was terrible that they could take such, like for a professional translation service, you need to have someone who's able to clarify that for them. Like they should have guessed it wasn't working. So detecting that was actually really, it saved us a lot of money in the future. In money we didn't lose. That is like not losing money is not something that people intuitively celebrate, but you really have to. The second one is tell people, look, I would only detect a 1 or 2% change. Your change is just 0.5%. Like maybe it's a good idea, but try to be bolder. You are here to tell people, try ambitious stuff. And they're not going to like it because every time they take a little bit of risk, they get it wrong and the senior management just slaps them and like it costs them an income. So nobody's really trying to be bold. But every time someone does something really messed up and lose a lot of money for the company, you celebrate. So you've got into the whole taking risk is a good idea. The second thing, and that is the best story I have, is A/B testing, experimentation in general, is like a trapeze net. I don't know if any of you have been to a circus. It is genuinely impressive. Like what those people are able to do is bonkers. I will never do that. I'm the guy who sets up the nets under those. Is it difficult? No. It's just simple thing. Simple nets, tense, make sure the tensile is good. That's it. That's done. You don't need to be physically strong. You just need to be here before the guy starts doing trapeze exercise. If someone gets something wrong, they get in the net and they go back up. They don't hurt themselves. Everybody's super happy. And we save the life. I will never go on a trapeze. I am not physically able. I'm not coordinated. Like I am the last person you want to have on a trapeze, but I can help someone train and get. The second thing about that image that is really good is trapeze requires years of exercise and falling a lot. If you start with that image with people, they're going to like implicitly they get, okay, I'm not going to get good at it within 2 weeks. I'm going to need years of practice to have good ideas. And most of them, it's not going to be good every time, but they're going to be really impressed by the possibility they could be trapeze artists. They're going to be really impressed they can do stuff that people think defy gravity. And this is, I've seen many examples of ideas that literally made the company hundreds of millions with really small ideas. Some of the best ideas are really simple and very counterintuitive. So having a test who's able to detect that and the culture that's able to try anything. If your idea is terrible, well, stop it. We'll have cake. Like you'll get fat, which probably is not good for a trapeze artist, but like we'll celebrate the fact that you had a really terrible idea and record it in time and we save the company money. That culture of it was hilarious is really good. I've like the best Jackass, the TV series, is maybe I date myself because I don't think anyone has heard about Jackass in this room. Hopefully not. But like this idea of like doing some pranks with like something that is stupid and dangerous, it's kind of the mindset you want to have. There was this TV show called Mythbusters that was a bit the same idea, but they were trying to prove wrong ideas. Hopefully it's still quite popular. And there's one image of Mythbusters that is exactly experimentation. Like I've asked anybody in that work and everybody says, that's my secret. That's the thing I have on my desktop to remind myself what I'm trying to do. It's the hero, the main character, who is like still there. And they were supposed to like rig some truck with some explosive and the whole thing like it went like he's clearly something terrible happened behind him. And he is smiling to the ears with a little notepad. And he says, the difference between messing things up in science is taking notes. And that's it. Hopefully the exercise around A/B testing was like the math was not too tedious, but that is the key idea behind A/B testing is take notes. And if you take notes, you can learn. And that is, I think, the last lesson around this. You've had really bad experiments. Celebrate the results. Tell people to be more ambitious, that you're here to catch if anything wrong happens. And please, please, please write down what happened so that other people can come back and learn from you. So before anything happens, train people, show them, explain to them statistical rigor. I understand that what I just showed you before in the notebook was not very clear. I'm going to show you a version that I think is much more impressive, much more interesting. use simulation, use stories. I'm going to tell you a ton of stories. There's a lot more stories. If you look at Ronnie Kohavi or any one of the founders of companies that sell A/B testing, that all tell how the experiments are run. Use the stories to tell your examples, not Greek letters and statistics. The important meeting you want to have is a seminar to review the A/B test. So you run multiple A/B tests, and then you have senior executive, typically the chief product officer or the director, that looks at every test, what the change was, what the result were. Most of the time at that point, the test is interrupted or continue, but the key thing in that test is to pick one of three: celebrate, iterate, or obliterate. Celebrate is presumably for successful ideas. This was really good. Here's what we thought it was. Just have a moment where everybody's in the room and you can say this was really a good idea. You can also celebrate like this was a terrible idea, but that falls more into the obliterate idea, which is like we tried many times. This is not the like this general idea. It makes sense, but like it doesn't seem to echo with our users. Let's move on and not do it anymore. That makes sense. The third option, which is the most common, I would say 80% of the time, is what you try to do made sense, but there's not your implementation. There were some details that you got wrong. So you try the tests. It's kind of a good idea. Yeah, like the difference is positive, but it's not significant. But it is significant in certain countries, or it's significant people with a big screen, or it's significant people who use Android, or it's significant people who use desktop, like whatever's the subdivision. And that tells you you have to think about better changes. You have to think about other improvements. This iterate is where all the lesson is not abandon the idea, but try to move on. Once again, use that meeting to celebrate value. Talk to the director, to the chief product officer ahead of time and say, here's like examples of tests that had really negative results. I know this is going to sound counterintuitive, but I want you to be smiling and positive and congratulate the team on teaching everybody an important lesson and begging them to stop the test because it's an expensive idea. But like try to have a comfortable, joking, happy atmosphere around it of celebrating because you caught it in time. If you fall from a trapeze and you're in the net, you're fine. You're not dead. That's good. Like this, try to have people into that mindset and really encourage senior executives to be there. If like ask them to be there before when they're there, be really supportive of their presence. Afterwards, thank them for their presence because during those tests, you're going to have situations that are tricky. You're going to have a lot of A/B tests that says it's increasing how much revenue we have, but it's lowering user satisfaction or the other way. Like you're going to have a lot of tense decision. Make sure that executives see that as an opportunity for them to say, we are a company where we'll always favor customer satisfaction over revenue or the other way around. I've worked with both types of company because at that point, that's where the decision happens. If they say this idea is costing us money, but the customers like it more, we're going forward. I will face the board, I will face the investors, but I want people to be, I want our customers to be happy because in the long term, that's more valuable. Launch, do it. That message, if there's an effective instruction, if it's repeated every month, wherever you have those experimentation review, is really going to resonate. People are going to be like, I know that if I have an idea that I think will make customers happy, even if it's not great for profitability, I know they will have my back because they've done it multiple times before. That really helps cement the value of the company, not what's written on the walls or in the document that you don't read on your first day, but actually the decision that I made. And if you tell executive, this is where you show people examples of why value matters, they will like it because it's really hard for them to actually do more than make a welcoming message on the first day that nobody listens to. For that seminar, for like when you're announcing and discussing results, this thing, 100%, it's an opportunity to discuss. So be ready, prepare. Like this is not a meeting that you can just walk in. Have a look at all the numbers, have a discussion with every one of the stakeholders, talk a bit to the executive so that we know what's going to happen before. This is not a meeting you want to improvise. There's a bit of a theater, like you know what's going to happen, but like let the stage and let the people speak loudly in front of everybody. That's really matter. You will, for every single experiment, be asked for a breakdown. Have the breakdown ready, or have an automated system. I'm going to walk you through what it looks like. Build an automated system, gives detailed results for everybody because everybody's going to want to have a detailed results. Another thing is when you do those, like when you show difference, almost everyone only shows screen capture. It makes sense for some changes, but most of the time it doesn't. So a lot of the change is actually architectural schema. Like you can go from this page to this page, like you remove these interactions, but nobody knows if it's common interactions to show how frequently people actually click on those interactions to have how people go from one page to another. A very common thing if you're a data scientist is you build recommendation engines or like any kind of like machine learning systems. Screen capture is not going to tell you what's the difference between two machine learning systems. You can have like, there's a couple of extra parameters that make sense. So for instance, if you do a recommendation system, show what are examples of queries or results where things are ranked completely differently. Try to find a way to explain like the kind of what the offline metric actually means. Because if you say we've got an F score of 5% more, nobody knows what an F score is, or an F1 score, like a top 5, like those are kind of counterintuitive. But if you say we try to recommend you a hotel, and for anyone who's booked a hotel that we consider expensive before, we're going to increase more expensive room, and here's how much we do it. Here's like, there's 5% of people that we consider like executives, and we tend to recommend rooms that are too small for them, so they tend to look for more fancy rooms. Like, here's like, illustrate with like clear examples that really will help people. And finally, that's the most important thing. Make sure that people fill in like the details, the thinking, the disappointments, the heartfelt around those different decisions in a document, store that document, and make that document searchable for later. Big companies have been able to be so big and so knowledgeable and so effective because they have a tremendous amount of embedded information into the employees, but employees circulate a lot. So available information for here's what happened 18 months ago. We tried this idea. Here's what we tried. Here's why it didn't work out. Here's why it fails. And if you want to try the same idea, you can look at the failures and look at the end. It's like, oh, okay, what I'm trying to do is quite different. Or I hesitated between two options. They tried one, so clearly that's not the right one I want to do. That's available after the fact documentation is absolutely priceless. This is all part of a larger structure of product thinking. So someone asked, where do your ideas for the test come from? Everywhere. User experience research. So you have people who are professional ethnographers in tech company who ask people, but you don't have to be a specialist, just talk to your users. That's really valuable. If you have a customer service team, I promise you, I don't know what their religion is. They have an altar with candles to make sure that certain problems are fixed, because they have absolutely ballistic customers who are really want you to fix something. I don't know what the problem is. It depends on every single company has their own, but trust me, spend 30 seconds at a customer call center or customer contact team. They know. They've built a religion around that problem, so they know. Analytics, look at what people do, look at what people work, look at when people stop using the service, what they did just before, look at there's a whole form of analysis to identify here's like clearly problems that are, and that's a very important thing, to have a document of pain points. List all the problems. You won't fix all of them, but you fix some of them, and have an idea of how big they are. Try to prioritize them using analytics. And for the bigger one, you have some sort of ideas. Then you have like big meetings with product people around which one we should prioritize, which one we should work on. You may or may not be part of that conversation, but then you have some ideas that are tested. Once again, bold ideas, atomic ideas, things that change meaningfully, but like simple changes, and A/B testers. And then you can have expensive lessons from experimentation that you use as documents that inform the pain points. And you have those future review meetings that teach everybody, here's what we tried, here's what worked, here's what doesn't work. This process is really valuable, but it comes at the end of like building an MVP is a lot of software engineering work sometimes. So be mindful when you tell people that the test wasn't effective, like be mindful of not throwing out the entire work they have. So ask them if like there was any kind of refactoring that can be released separately, or like trying to be intelligent in how you want to do, because there is multiple very professional people with like decades of experience in their craft that you're saying no to. So try to be considerate in what you're trying to do. Two really valuable examples of what that looks like. So recently, that's the most recent, Shay Sharma, who worked at Airbnb and has since been the co-founder of Apple, which is offers A/B testing as a service, has a really good conversation. Here's a link to his 1-hour interview about why he started, like he's got really good example experiments and all the culture around it, all this question about thinking about products, the kind of interaction you can have with different stakeholders. He talks about it quite meaningfully. It's one of the 30 or so, I think I've got 35 now, videos. So there's a month long of videos on A/B testing that I'm curating. Anytime I see a video that is meaningful, there's a lot of like A/B testing in 5 minutes video. It's not that they're not valuable, but they're not really answering the actual questions that people have, or like they always give the same answer. This curated list has a lot of videos from people who've been doing it for thousands of experiments, and they have like some meaningful lessons around what works and doesn't work. Working on this better product thinking so that you have better ideas is going to be really important. I'm going to come back to it again and again. This is A/B testing makes that process better more than anything else. It is a heartstone to craft again, but that was the valuable one. The real art of you as in charge of being an A/B testing someone with familiarity with the data and how to go thing is less in a statistical test, although that's valuable and you should be able to explain it. I'm going to go back to it soon, but more in the goal. What is it that you're trying to do? So I used the example, and I'm going to continue using conversion rates. It's never a really good goal in general because it's kind of a good idea, but like it's just slightly misaligned with other things. What you want to do is think about all the things you want to look at that together make a good criteria. So what's called an overall evaluation criteria. It's not just one goal, it's multiple goals. Some of them you just want the number to go higher. So more conversion is good, more people spending more profits is good, but it's not just that. Are you affecting other stuff negatively? So one really good example of a complementary to the conversion rates is the average basket value. If you tell people, oh, here's like a very cheap stuff for like $1, you're going to increase conversion rates because a lot more people are going to buy cheap stuff for $1. But this is not really what you want. You're going to spend more in traffic. Like there's cheap and easy way to increase conversion rate that is not what your company actually wants. So you want to think about those more. That is like a really obvious example, but there's plenty of those. The most famous one is so Ronnie Kohavi, which is the father figure in the entire experimentation space, was pretty effective at running experimentation at Amazon, and then he went to Microsoft, and he arrived at Bing, and he asked, like, what is the objective metric? What is it that we're trying to move? And unanimously, everybody said time on site. I was like, oh, that's cool. Do we want to increase it, or do we want to lower it? Because Google famously wants you to be as little time as possible on Google because they want you to find faster. But Microsoft, with like MSN Online, there was a portal, they wanted you to spend more time so that you could click on more ads. So is it more time on the site or less time on the site? And then the room erupted in a fist fight because half of the room said obviously wanted higher and the other room said obviously wanted lower. So that was eventful, but he managed to get them to understand that this was not a good objective, even if everybody thought it was the perfect one and if we didn't think about changing around anything. And so they kind of moved to two other objectives that kind of makes sense. The first one was what I call share of search ratio, which is just number of searches, roughly. Makes sense. They have an estimation for how much the Google got, and it was like, basically, do we get more searches than Google? And the other one was revenue from advertising, which is simple, effective revenue. That kind of makes sense. One time they run a test, and like basically the test broke something. It wasn't really important, but they realized that if you basically have worse off search results, people look for something, they cannot find it, so they search again because they have like more, they try to specify a bit more, and they try to like make more sense. So like it's a frustrating experience, but you end up with having a lot more queries. The second thing is because what people are looking for is not really appearing on the listing site. They end up clicking on ads because if you don't have what you want, you're going to click on something else. Like there's kind of like a communicating water-based phenomena with the clicks. And so if you basically break relevancy on a search engine, you're going to increase both the number of queries and the number of revenues. Once they had that, they realized that those two really obvious searches were not necessarily the one that we're looking for. And so they realized that for revenue was going to be a bit different, but for searches, they had to break it down into three metrics that had to be modified in one. The first one was queries per session. Sorry, I got it wrong. So don't look, should be I cannot modify anywhere from. Queries per session, less is better. Someone shows up, they want something. If they get the result immediately, they're happier. So queries per session, they want less is better. But there's have a hard limit on at least one, if I'm being honest. So this is where I mistyped. I'm really sorry, so I need to edit that. Is sessions per user per month. Actually, I should be able to do it here and now. Look, can you see my? See if I can. Sorry about that. More better. Sessions per user per month. So do people come back? That is because of satisfaction. They're confident that Bing is going to give them. They have more ideas of things to search. That is the one they wanted to increase. That's the one that makes more sense. So they didn't want to increase the number of searches. They wanted to increase the number of sessions. But the number of queries, which is related to revenue, is making more sense. And then active user per month, same thing. More is better. That's just basically retention. That's how you measure satisfaction if you don't have like actual satisfaction. That kind of, okay, wait. We understand the business. We're not entirely sure exactly which direction should go where. let's break it down so that we have atomic measurements that we directionally make sense is really valuable and useful, because that way you can tell here's the actual effect that you're having. Like you frustrating people, so they search more, but they search more per times that they don't come back on the website, because last time it was like 15 queries to actually get the wanted. So what looked like a wash off was actually a really meaningful and programmatic effect. Another example of like having the right kind of metric and make sense is Google had like similar programmatic, and for the search engine result page, so SERP, that's the industry term, they were able to run 10, but more than that was difficult. They managed to do the engineering work to increase it to 20, and it had negative impact. And they were really frustrated because like more search is better. We want people to be informed, to find, and like we give them more results, and they don't like it. They were really frustrated. And not until they actually broke down the problem into, is it because the web page loads slower? Is it because people are less likely to click on the first page? Do they scroll? How far they scroll? And to understand the difference between 10 and 20 in detail, they understood what the problem was. The problem wasn't that you were giving more options, although the options, most people didn't see them because they were still on the page. It was because fetching 20 results took a fraction of the time more, milliseconds. And that meant the web page was fractions of milliseconds slower. But that didn't feel sensitive. But someone was like, is actually, slow search result, is it a problem at that scale? There was Google, there were plenty of engineers that cared about like being as effective as possible. No one at the company thought that. I think it was 5 milliseconds, something completely ridiculous. Nobody thought that was meaningful. I think 10 milliseconds. And so I think she was not an intern, but she was she was really junior project manager at the time, Marissa Meyer, who ended up being senior, very senior at Google and then Yahoo. The first thing she said, it was like, we can slow the websites and check. What she did horrified everybody. I think like people just were scandalized that she was right, is that she basically added wait for 10 milliseconds before serving the web page, a sleep tense, in the code. And people were like, this is the stupidest A/B test I've ever heard about. And she was like, I know that it's going to be worse off. I don't think it's a good idea, but nobody can tell me how bad an idea it is. I'm not doing an A/B test because I want to do an A/B. I want to release the waiting longer than release the web page. I'm doing that to know how much worse off. And the results were catastrophic. Big surprise. And as I told you, big surprise means cake, everybody's super happy. Because basically she told Google, you think that you're super engineering focused. You think that performance is everything. You want a website that is like so fast, nobody understands how it's physically possible to do it. You're wrong. It's more than that. It's more important than that. Even you underestimate how valuable it is to have a website that is blazingly fast. Slowing the website for 10 milliseconds is actually having more impact on customer satisfaction on how much they click and how much they come back than you expect. So they remove the sleep, it's not there anymore, but actually they regularly retry the website on a different aspect to check how sensitive people are. But that idea of doing a negative test, of doing a regression, of removing something that everybody believes is valuable to measure the difference is incredibly important. And this is only informed by the idea, like it's not the change that matters, it's your goal. What is your goal? That's twisting. A/B tests focus a little bit too much on what is it that you're changing and not enough on what is it that you're measuring. What is it that you're measuring is super important and a lot less counterintuitive and a lot more counterintuitive when you think. One example of this that is, it doesn't matter which company you're going to work for, this is going to be a problem. And I'm in the receiving end. So for the love of everything that is holy, please, please, please look into it as soon as you can. Emails. Every company sends emails to customers and people click on those emails and then they end up on a website. And people are like, oh, emails work. They drag people back to our websites. It's the best marketing we have. Here's a lot of money for the email team to keep sending an astounding amount of emails. I worked at booking.com, so trust me, I know how bad a problem it is. That amount of email is way too much because nobody cares what is the cost of sending those emails. And the company that was sending too many emails, I won't mention them. At some point, someone was like, I'm tired of getting so many emails. So the experiment was, we're going to, every email that is going out, other than the one that like are transactional, so like confirming that you actually like stuff that is like the V8, like receipts and stuff like that. Other than those, all the marketing emails, the email is going to be about to be sent, and then we have a little system that says, I'm going to roll a dice, and if it's 1 or 2, I'm not going to send an email. Or if it's 1 or 2 or 3, I'm not going to send an email. Like the old test was a bit confusing, but it was basically, we're not going to send most emails. Literally, we're going to reduce the amount of email we send by a vast amount. And everybody was, this is a horrible, why would you do that? Everybody's horrified. You know what happened? we made more money through emails because we had few people who received certain emails that they unsubscribed. And so we realized the math is not if they click on emails, they get it, is how many people unsubscribe. And if they didn't subscribe, how many emails we could have sent to those people and how much money would have made from them sending those emails back. That was the lifetime value. There was mathematically, it was non-trivial because it was like long-term. The whole thing required a little bit of thinking about what was the actual objective. But the intuition was very simple. If rather than sending emails every single time we can, we think about when is it relevant, when will people actually care, you end up with a very effective situation that makes a lot more sense. The most hilarious experiments at the one time, because one thing you will hear a lot from people is, because you test and you have many metrics and people are like, this is the metric I'm trying to improve, and that metric doesn't improve, and then another metric improve. And every single time it's like, what if I choose that? Not that I know which one is the winner. What if I pick the other horse after the race kind of situation? And everybody who runs is like, that's not how things work. You have to decide what is your change and what is your metric before the race starts. You have to, one time where there was the case. It was an e-commerce website with like very difficult to have exclusive products. And so the most common problem we had is item is not available. The solution was reasonably obvious because when we did with like customers were complaining about it a lot, like we the customer service, we asked them what is the biggest problem they had. For the love of everything, like, could you please do something about items not available? That was clearly the biggest problem. And there was a young product manager. He showed up, and I think it was his first job or something like that. It was like, we could just add an email, like tell people, send me a text message, send me an email when the product is back in stock. Honestly, when I heard about it, that was the best idea since sliced bread. Everybody was like, this is the best idea. This is your first test. Congratulations, it's going to be amazing. He looks at it, and we're not supposed to look early, but he looked early, and he is green. Like, I've seen a ghost. And like, what happened? And he showed me the results, and I have like clearly super negative results. And I'm like, don't phone. I'm like, it's really, why would? And then in front of him, what he was like, I'm barely a month in this new job. I am 100% going to get fired. What happened to me? I burst out laughing. The metric he had picked for his test was, as well as the test that was the website, conversion rate. Let me repeat that. Someone shows up on a website. They want to find something. We say, oh, we know what you're talking about. We had it. We don't have it anymore. But we're going to call you back when we have it. And we decided this is a successful interaction if they buy something else right now. The conversion rate was the conversion rate within the same web sessions. So of course, that number is going to go down. If you tell people, oh, no, we know what you're talking about. We're going to tell you about it. Like, you're going to get it just not now, but later. Of course, they're not going to buy today. That is like obvious. What he should have picked as an objective was conversion rate. So we knew most of our attempts came back within 10 days. So like conversion rate within 15 days. It took us a bit longer to get that number, but like that was obviously the goal that he was having to have. Like this was like clearly. So for the first time and the only time in my career, I said, no, we're going to change the objective metric on your test. I know, like, it's just, you picked obviously the wrong one. But that was such like a comical situation of like, dude, of course it's not, like, of course you're measuring the wrong thing. And stuff like that happens a lot. I've seen a lot of websites where like they added the price or they added like more information on the product listing page. So you have two types of page on e-commerce. You have many products with like small amounts of detail, and you click and you have more details on the product side. So product detail page, product listing page, PLP, product detail page, PDP. Now that's e-commerce, a very common thing. And so every time I hear a test about taking information from the product description page to the product listing page, PDP to PLP, every time someone look at the conversion rate between product listing page and product, and that one is always going to tank because people have the information they want, so they know what is happening. The actual relevant conversion rate for that one is, do they end up buying anything because they have more information, they have more relevant information, if that pushes them to buy the thing they actually want, or the lack of return or whatever you have. But like, it's not this instant conversion rate. So you want to think, what is it that you try to affect, and how do you measure what this thing is trying to affect, and not just like the metric that is closest to what you're trying to do. But of all those things about how to set the right metric, I think the most important one is the story is not true, because I'm familiar with both companies and I work for one of them. So, but it's a very important one when you're trying to think about how to set metrics for an entire company. the head of product at Optimizely, which was a service that sells A/B testing as a service, gave example to their client like, you can have different philosophy, like your metric defines who you are as a company as a philosophy. And there's two companies that sell roughly the same idea, but they're very different companies because they have a different metric, objective metric, Airbnb and Booking.com. Airbnb, if you go still now, it's very aspirational. You go there, you have wonderful places, you're going to meet some great people. You don't feel like something bad is going to happen to you. You feel like you're going to meet, like you're going to have the time of your life. As a website, it is really enjoyable. Booking.com, different story. Depends a bit, but most of the time, you feel like something terrible is going to happen. Like you have big yellow pop-ups saying, this is the last time, this is the last room in the hotel, so if you don't book them now, you're never going to go on holidays. You have like counters, you have a lot of things that are kind of stressful. And John Arona's attributes the difference between those two websites to the fact that they have different objectives. Both of them is conversion rate. Booking.com is conversion rate per session, and Airbnb is conversion rate within 2 weeks. So Airbnb has to wait a little bit longer to get the test results. But if people feel reassured, they feel less pressure to fill in here and now. And the kind of web changes that increase that number are very different than the kind of changes that increase the conversion rate per session. Having a countdown tells people if you don't book now, you're never going to book it. And actually, it makes sense for Booking.com because a lot of traffic on Booking.com is paid advertising. You go on Google, you give some money, Booking gives $50. It's usually that amount, it's a large amount of money to get you from Google to Booking.com. So if they do not get their $50 back by selling you a hotel room, they're losing money. And so it kind of makes sense for them to have more short-term metrics. It's not exactly, if you work with people Booking, they tell you that story is not true, but there's a clear direction in how do you think about the metrics, what they really incentivize. And for every company I worked for, there was far more management, philosophy, direction of the way the company is going through those interactions than not. And even if what you're looking at, when I was at Facebook, I spent a crazy amount of time thinking what were meaningful interactions with people. Most of my time there was, how do we define those people are having a good time and they're talking to friends and it's people they care about? Like, what was a post that you like that was, I've seen your birthday post that I don't care, to like, I understand your cat is dead and I'm here for you. Trying to get into like people's head and thinking, how do we tell those two apart? I spent a crazy amount. And trust me, there are hundreds of people at Facebook and Instagram that I try to think how those things work. But because then don't always win, because of things that slightly misaligned, you get to a point where like getting people to click on anything, getting people to get engaged, no matter cost, kind of gets into that. And the sentence you'll hear a lot, and it's less and less an exaggeration, is gambling and hookers. You have more people that wear very tight bikinis on Instagram than anyone would like. You have more advertising for gambling, actual gambling, crypto, which is not much more different on those websites, because those are things that work. And they end up like telling whichever system decides what you see on Facebook, Instagram, all those websites that you care about. And that is a genuine problem. That is not a problem that is easy to fix by just saying, oh, we're going to ban those systems, because then you're going to have something that is just less, attracts attention, like controversy, political dynamics. An example that is quite, I wasn't part of it, but I've seen a lot of conversation on WhatsApp around how big a group can be. And it's just a metric like that. It doesn't feel like it won on like a ton of very interesting things. And you had people that were like elected officials that were quite active into getting the group to be higher, bigger, because they expected political impacts on how big the group was. So you have some things that the type of interaction in big groups, and I'm saying that some small groups and some political parties benefit from one or the others. That kind of conversation can be really uncomfortable. And so you want to be mindful when working in a company to be like, what am I pushing towards? Because you underestimate how much impact you have by having those measures. The most meaningful change I've done for any company is to redefine what should be the objective, breaking down so that people have more legibility, make sure it aligns with what people are actually trying to do. Like, question is, walk me through what happens to a customer once your experiment, what you're trying to change actually happens. Is that changing the metric you care about? And telling people what is the long-term perspective you have on those metrics. So good overall evaluation criteria is like, can be a bit counterintuitive, but essentially one key lead metric. They have lead and lag metrics. So lead metric is something that happens reasonably fast, something you can measure now. So like, do people convert? And lag metric is something that will happen later. So lead metric can be, are they clicking, I'm happy about my holiday, and a year later they might book again using the service. So that would be a lag metric. Financially, you care about the lag metric because that's when you get money, but the lead metric, you get it faster, so that makes no sense. One really good example, I work for Deliveroo, which is a company that does food delivery. Our lead metric for a lot of situations was lateness. So because that was people care about. They wanted the food, they wanted it now. And so if the food wasn't late, they were happy and they're more likely to reorder 2-3 weeks down the line. We couldn't wait 2-3 weeks for some of those tests. So having how late the food was a really good proxy for a lot of the, are we doing okay on the delivery situation? What you want to have on top of 1 or 2 lead health metrics actually influenced directly by what you're trying to do is health metrics. No regression. So you can you get people to book more, but do they call more to customer service? Because you forgot to tell them important information and now they have to cancel. So those health metrics really matter. Do they end up coming back? The satisfaction, the metrics are not directly related, but could be impacted by what you're trying to do. Do you have more spam? Do you have people engage in stuff, to click on stuff that you don't want them to click on because it's not healthy? Those health metrics, you don't expect them to change every time because you're not actively trying to prevent spam with a new recommendation engine, but you want to make sure that it doesn't have any kind of negative effect. And you can have hundreds of metrics. Without any illustration, big tech company have thousands. I believe Google has 10,000 of extra metrics. Most of them are not necessarily relevant, but it's good to have them handy as just predefined if it's convenient with your engineering, pre-computed, so that you can actually debug and make sense of it, but don't necessarily make decisions based on those. Try to make sense of it because they're going to be, so building the overall metric system is a kind of complicated system. As I mentioned, my workshop is using synthetic data, so there's not much examples. But when you're running experiments, you're going to have the same kind of the timestamp, unique ID for the unit you care about, which has the key information, so events or page loaded in my example, and attribution. So what is the variance? Which one is control, which one is treatment? My example is really the simulations and data is useful to prove a point. We're going to go through permutation. So it's a good thing to keep in mind. Should I simulate data to prove a point because I'm trying to give an example? And you can control exactly what happens. But if you actually want to run tests, you're going to have to deal with your companies. There's a ton of idiosyncrasies, but as long as you have those 4 key elements, you should be able to run a lot of the tests you care about. Getting the attribution is probably the hardest one for all sorts of reasons, because that information is not necessarily conveniently located. The website that I present, here's the shape of the website in case I wanted to present it earlier, but I forgot. You have a home website. People can go to see product A, product B. Some of them end up doing cart payment confirmation. At any point of those, they can just end. That's the end of the session, and they don't come back. So what I would recommend, this is something that's useful for you to understand the synthetic data I have. My recommendation, if you have your own interaction, is to draw similar with the thickness of the arrows, depending on how much interaction you have. You have libraries to do that, to help people understand a little bit better what's happening, and to help people understand a bit better where the traffic goes, and how many people go every month on those, or how many unique visitors, how many visits, so that people get a better sense of what the data, what are the idiosyncrasies, and have which one of the events that you actually track. So I've had so many people want me to do experiments where we didn't have any tracking, and they ask, is that a problem? And I had to walk them slowly through why not having data was really problematic for beyond the fact that it's a synthetic data. As you should have seen from my first demonstration, hopefully it's going to be less tedious in the next demonstration, building a report is a lot of data engineering. That's the bulk of the physical efforts of the computation cost and the amount of data that comes back. It really depends on how the data is structured. But my one advice is, if you have a data engineer, walk them through what you're trying to do and ask them for help. Because it might it's a whole job, and you have 5 jobs already as the lead scientist, or whatever your job title is, a product analyst or experimentation specialist or experimentation advocate. Having someone else where you can talk about that aspect of your job, or how to manage data, would make sense. And most likely they already have pipelines that does most of what you want. The only thing that you have to add to them is to say, I have this, whether someone in treatment variant for each experiment, I have to get through the process, so that extra data they have to process, but they have a bulk of the tool. It really makes sense. And if your data is structured differently, if there's any kind of change, if your data is not like my demo, they're going to be able to see that immediately and help you make sense of it. The other reason why you want to ask data engineers is because they're responsible for the cost of data engineering. It's usually a big cost at companies. You're going to basically multiply that cost for every single experiment you do. And if you have categories or more metrics, it's just even more. So you very easily make that team 10 times bigger in terms of how much demands they have. So having them notice this is happening, having them optimize around it really makes sense. It is hard to imagine how much, if you don't do it smart, if you don't optimize, it can make sense. But there are optimization techniques. Big companies have published papers around, here's how we actually compute our A/B test results, because doing it naively is just not scaling if you have billions of users. That is a very specific problem. It's unlikely you have it, but if you work for a company that is starting A/B tests and has millions or billions of users, thinking about that can help if you run a lot of tests. And finally, and I've said that many times, but I'm going to say it again, it's reasonably easy to unload the problem of data engineering to someone who knows what they're doing, so that's really good. But attribution, who is part of which treatment, who is control, who is treatment for each experiment, when were they assigned, when they who's a bot, those are insanely hard problem. And that is assuming that you know who's who. If you have proper login, if people don't use weird VPNs, connect from random websites, connect from internet cafes, people have multiple devices, it's going to be difficult, but it's manageable. If people start deleting cookies or have weird privacy protecting system, it's going to get bad really fast. So some people use session level metrics, so don't have to deal with users, but it's not necessarily perfect. There's a ton of things you can do around it, but it's very easily a insanely difficult problem because you have multiple things making each other more complicated. Basically, if your goal is to get results and get data and make sense, you have two objectives that are slightly different. The first one is to have ground truth on summary statistics. So when I run the data, I basically had, here's how many people saw, and here's the conversion rate they had. No statistics, just no statistical numbers, no Greek letters, just totals and conversion rates. Getting that, can get everybody to agree, this is the reference point, this is truthful, there's not bots, there's not fake, there's not any kind of issue, there's not double exposures, there's not a lot of the complication that attribution can make hard, those numbers are true, is not very exciting, but really, really valuable. Have, if you can, a team that does that. Have data engineers make sure that everybody agrees this is a reference point, so that everybody knows this is what's happening. Then you can have a layer of statistics, the t-tests, the z-tests, the many corrections that I'm going to talk about after this one. It's very likely you have data scientists, and some of them have strong opinions, and they want to use Bayesian technique, they want to use multi-ambandit, they want to use other techniques. God bless them. Let them do. Just make sure that they understand that you're doing 90% of the work, and they're welcome to do the 10% remaining the way they want. They should. It's a really good exercise. Have discussions about it, have discussed the right goals, the right methods, have them pick the right goal objectives. And if they want different objectives, do the hard work of computing that metric for them. But separate the two things because they're two very different problems. One is a data engineering problem, the other one is a statistical problem, and just make sure that the two are separated and connected with whatever service you want to have. An API is a really good example. So one thing I've worked for multiple companies that were doing A/B testing as a service, and what I've always saw is all the weird questions you have from data scientists who want to do the thing they want to, what they actually want is not for you to do it. They want to do them themselves, but they want to have access to raw data, which is typically not easy to get because those companies don't necessarily think this is something that people care about, because a lot of the added value is on this interpretation side of things, and it kind of is. But for data scientists, they want to do things that they own. So also having access to that raw data is really valuable. One typical example of the kind of architecture you have, this is not the only one, is you have a service that actually handles payment or showing displays, like a recommendation engine or whatever. So if the payment system is you want to run a test on Apple Pay, so it has the ability to show some users Apple Pay, but they don't know which one. It's not the team that builds the payment system doesn't decide who sees what. The way it works is you typically have another service, typically authentication service, that allows you to know who's who, where they're coming from, what's the IP, are they authenticated, which user it is. If they have multiple devices, you would be able to have the same user on multiple devices. So that's a separate service. So that's typically a front-end team that has that own system. That service is a godsend if it works well, because it is incredibly difficult to do well, and that's going to have a lot of limits. But it's able to say, here's what we know about the user, here's the OS they're using, here's where they're connecting from. Get all that information and feed that into a feature flag architecture, which is a system that is able to say, for every service in the system, I'm able to say, for those users, show them this feature, don't show them this feature, based on all sorts of aspects. So when you do a release, typically what happens is, the old way was you have a code and then you had a new version of the code, and only the people working on it had a new version of the code. And that was very problematic because when you wanted to do a release, you had to send everybody the code, and that took a really long time. So the process of copying and promulgating the code on everyone's computer, everyone's server, was too long. The new way of doing things is everybody has the latest version of the code, or whatever is the version that is minutes old. So every single change is given to everybody all the time on people's server. People go on a website and they get the latest version of the server set the latest version, but they only see what the feature flag system, the gates they're called, is allowing them to see. And those say, okay, I know which user it is, I know which OS they're using, I know which country they're coming from, and the project manager decides only people who work on Apple Pay are allowed to see Apple Pay because they're trying to debug the system. And until the system is not considered reasonable and debuggable, nobody else has access to it. So you have like individual, I've got 5 engineers in my team, so all 5 of them are able to see. Everybody else has the software, has the ability, but they don't see that version. That's how the feature flag system works. So everybody has code with like if statement, and if statement is ignored for everybody except the 5 people working on a new version. And that's how you have leaks on, oh, they're working on the solution. It's people looking at the code, ignoring the feature flag. Once the team actually works on it and say, okay, this is actually working, typically what happens is every employee or like a source set of people get it so that you can test it. And then if the release is a bit bigger, then you have like more people have access to it. And the little hack, if you have a system like that, is to say, okay, once you get to serious talk, when you go to show to everybody, don't show it to everybody. Turn, okay, you want to test it on like, so Apple Pay is only empty, so it's not on Windows, but on Mac, you don't know. Turn it on and off in certain, like randomized in certain countries. So you have a system, this feature flag system allows you to get experimentation for almost for free. You just have to have this extra option of randomize who sees what. It's not who sees one, those people can see, those people don't see. It's those people are randomized. And that allows you to have, so if you want to make an A/B test only for people in Germany who have an iPhone or who have a Mac, which would be the right population to test Apple Pay, then the service would be able to say, should that person see Apple Pay? And for a lot of people also not working on it, not in the right country, not the right device, nope. Oh, this person is in Germany, this person see. For half of them, you're going to be able to see control. For half of them, you're going to see treatment. So half of them don't see Apple Pay, half of them see Apple Pay. And that information is then relayed to a database that actually stores which user saw what. Which user was excluded because they didn't have the right kind of device, which user was excluded because they didn't have the right kind of geography, and which user was part of the experiment, and they're part of the experiment, or their control, or their treatment. So that whole architecture is reasonably common. You have some small differences. Sometimes the attribution comes of a feature flag system. But typically, because you have multiple services, you have to understand who can do what. And that allows you to have systems that don't have too much to do, because authentication only tries to figure out who are their customers. What do I know about them? Feature flag is only, given what I know about customers, who sees what. Service is, I know how to, how the payment system, what payment system I have. And for every payment system, I ask someone else, should I show that to that person? And the attribution is just a database that stores information. So those 4 things work together, but they all have a very simple way of working, and that makes things a lot simpler. That's understanding of architecture is something that you want to have backend DevOps people walk you through what would be the right solution for you, because this is not something you're going to be able to improvise. You have 90% of that is already existing, and hopefully you have a feature flag system. If you have that case, then it's very easy to implement implementation with just one element of randomness in the feature flag. That's all. And the rest is well maintained by the feature flag system. And a lot of the big tech company, they stumbled on experimentation because they had this feature flag system that was working, like, oh, we can easily do experimentation. We can easily gather the right kind of data because we already have 90% of the work. Cool. It's been a reasonably long, I have no idea of the time. How are we doing on time?
We're 2 hours, 40 minutes into the.
Okay, so do we want to switch to questions?
But do you want to take a 10-minute break? I mean, you've been continuously speaking for quite some time.
I'm good. But we can take the last 20 minutes for questions.
Okay. Okay, we have Rajiv with a pretty long question. Rajiv, do you want to? Bertil, do you mind if I unmute Rajiv?
Go for it. I'll have my tea.
Okay, Rajiv, would it be okay to speak? I have. Okay, Rajiv's not here.
I can read up Rajiv's question if he's not. I read somewhere that permutation and bootstrapping methods make inference without making strict parametric assumptions about the data, and hence more powerful and versatile than the parametric test, t-test, chi-square, and over z-test. Is that correct? Are they followed in the industry, and can we just not replace them with parametric A/B testing? Rajiv, this is such a wonderful question, because that's exactly what I wanted to go through now. An hour and a half left, so I to go through the whole thing. But if you open my, it's actually a new share. Look, I'm hoping I'm showing the right one. Oh. If you are kind enough to go through the many AA test, that is a permutation test. That is what you're talking about. The idea behind a permutation test that I think is a lot more intuitive than the what I showed you about statistics is that you don't make the assumptions that you have to make. And there's a ton of assumptions that I didn't really mention around independence, around those things. And those assumptions, that's a big secret, are usually wrong. What this notebook is doing, and hopefully there's enough explanation, is essentially the same thing. And then you have the result of the A/B test. So until then, it's exactly the same as the one before. Sorry, I like copy pasting code. And then what I thought about doing was take the same event, look at how many users we have, and then, so we have a loop on n. N is 30 here, but typically you want to have it 1,000 times or 10,000 times. And you take users, and choice is a random function. So you randomly assign control and treatment to every user. You take the same data set I was using until then, and you basically give to every, you resample which one is part of control, which one is part of treatment. That is the idea behind a permutation test. And then you just apply the same compute test, and you look at all the results together. So here's the test. So I've done it 10,000 times while we're waiting. Sorry. What? Oh, cool. So you see results is not stored. Okay, there was a stored pen test. Seems to have a technical issue there. Sorry about that. But it gives you an ability to see what is the difference that I measure on this test where I've randomly decided who was part of control, who was part of treatment. So no weird abstraction in statistics. Simply, I look at the last 2 months of data of my company, and I assign half of them to control, half of them to treatment. They should be the same. You're not asking anyone to believe in Greek letters or anything. I looked at the past 2 months of data. I looked at this conversion rate metric. So this is a measure of conversion rate. And I look at what's the difference. So most of them are around 0% difference between conversion and treatment. Some of them are a little bit above, some because of randomness, some are a little bit above, some are a little bit below. So this curve doesn't look really impressive because I've only done 50 times. I was previous tried 50 times, then 10,000 times broke because of memory issues. But if you continue doing it, you're going to see the same shape as you've seen for the t-test. That means that the assumptions that we made for the t-test were true. But doing it this way with a permutation test, with the bootstrapping, you don't have to make those assumptions, but it's a lot more tedious. So you just have to say, I look at the last 2 weeks or 1 month of data, I randomize my test, and I do it 10,000 times. So I split who's part of control, is part of treatment 10,000 times, and I end up with the same bell-shaped curve. And that is a way for you to confirm, yes, the t-test assumption is true because I end up with the same shape, or if you don't end up with the same shape, which happens sometimes, or if the shape is a little bit wider, which is typically what happens, then you know the t-test assumption wasn't true. The most common way this happens is if you have a travel website, or like a website or a house, buying a house, like anything that requires a little bit of consideration, like large investment or like luxury items where people would go and they would say, oh, this is a really nice bag, or this is really nice shoes, I want to come back and buy them in the end. And you say, okay, every session is independent. So what people does in one session doesn't matter when they're doing again in another session because your users are not plugged in. So you cannot match users to successive sessions easily. So you just ignore it and say, I'm going to do A/B tests on sessions. But if someone comes, see something, someone comes again, see something, someone comes again and see something. At some point when they saw that they had a new version that had bigger photos, they like those shoes and they end up buying the expensive shoes because they're much nicer. And then a session later, they end up buying something, not because that session has higher definition images that has an impact on the decision. Then you end up mixing the impact you had on one session with the result on another session. And so you made the assumption that the sessions were independent where they were not independent, and you end up with a curve that is not the same shape as a T-curve. Typically what happens is it's the same hat shape, but it's flatter and wider. So you end up with an experiment that is less accurate. And when you run a permutation test, it allows you to check for this. But as you can tell from the error message you're seeing on my screen now, it just requires you to do this very simple math, randomly looking at past data and pretending that you're doing a test where you're not doing. So that's called an A test 10,000 times, which is just computationally expensive. So that's why a lot of people don't do it. I would strongly, strongly recommend, and everybody I know who's in the expert domain says, please, please, please run A/B test before you do it. The way you do it is whenever someone introduces a new metric, you say, does that metric work with that test? So you run an A test with that metric and with different units. So typically it's per user or per session. Another common metric is household. So if you are supermarkets and you offer rebates to my partner, but not rebate to me, she's the one who's going to do the grocery now because she's got the rebate on me. So like you have contamination between members of the same household. That's the kind of reasoning behind using the gloss. So if you are Uber, for instance, they do experiments per zone, because if you tell taxi to go somewhere, then like you have influence per zone, so they do experiments per zone. So that's the unit. So you have, whenever you have a new metric, whenever you have a new unit, you see, does that metric and that unique pair? If we do a permutation test, do we get what we expect or not? So that test presumably end up with like, here's the distribution of differences, and that standard deviation should be what we expect from the other test. Presumably that's how you can check that it makes sense. But you have statistical tests to check that the shape is actually what you want. It's just, you don't do that with like 50 cases like this one. You would have to run the system for 10,000. But my recommendation is run permutation tests as pedagogical tool, because you don't make any statistical assumption, and you explain to people, I'm not saying that 0.25 difference is not meaningful. It's just, this is what happens when we test nothing. Like I literally tested nothing and this is the result that came out. So if your mean super sub feature has the same impact as nothing, we can all agree of like, it's, I'm not being a dick about statistical openness. It's just, you're not changing anything. But if that curve is not what you expect with the statistics, then you have a problem. And then you only want to use that curve and not the t-test. But if the t-test and that curve make sense, then use the t-test, because the t-test is just faster. That's the reality of the permutation. It's just super computationally expensive. And so my recommendation is run one to check that it's okay when you introduce your new metric. And after that, document that it's what you expected. And after that, have your test run on actual statistic. The reason you want to use like new test is that you want to run for like short, like a week, a month, 3 months, but you don't want to run every single time duration of every experiment. While for t-test, it's very easy to have like a result for any kind of duration. So you have like small differences like that you want to make using t-test when you know it's reliable makes sense. Same thing for chi-square, which is use chi-square if you're trying to compare categories, not metrics. And z-test is the same thing as t-test. It's just it's the reasonable case of a t-test. A t-test, you have degrees of freedom. Z, as you're assuming that you have too many degrees of freedom for it to care. But yes, I agree with you, Rajiv. That is a really good idea. Any other questions that you think would be valuable?
We have Nireen. Nireen, have unmuted you. I've given you the permission to speak.
Is what it actually looks like with 1,000 test points.
Yeah.
Yaran? If you unmute, you can speak.
Yeah, Nireen, can you hear me? Would you like to ask your question? Okay. Meanwhile, did anybody else have any questions? Please feel free to raise your hand. I will unmute you and you could go ahead and ask Bertil. Okay. Okay, we don't have any more questions. Bertil, did you want to wind up? Any last words?
Yep. So if you go through the different templates, so I've talked about the many A test, so that's essentially running test, and you have the ability to answer why do a 50-50 split. You have another one about power analysis, which is you take the same data of like having 1,000 experiments with like different differences, and you have also the minimal detectable effect. If you add up the difference and the minimal detectable effect, you have how much of an impact your test need to have been detected in any one of those 10,000 cases. And so that's the minimum difference. Sorry, that is the minimal detectable effect for that experiment, which is about 0.7 something. And if you add up the two, then for some tests, no impact would have been detected. So that's a 5% of tests that are always detected if you have an impact. But if you have more of an impact, see 0.5% or 1% or something, then sometimes you would have detected it. If you do cumulative case, then you have the more impact you have, the more chance you have of being detected until like a really big effect that is always detected 100%. This is the power curve. It starts at 5% because you always have a percent detecting no effect. That's how you define 5%. And it goes up and up and up and up until it's close to 1%. And a lot of people talk about the minimum detectable effect, MT, which is computed like we did before with like multiplying the standard deviation by 1.5, 1.96. But a more useful thing is to run this power curve and say, what is at 80%? And that tells you if you run a test and you have an impact of at least 0.1%, then 80% of the time you will detect that change. And that is a way to tell your customers, here's what I really mean when I'm being annoying about the statistic. I've actually run examples, and if your change is no change, I won't detect anything. If it's a little bit of change, I might detect it, but I might tell you this is not significant, and you will be disappointed. But if you want it to be significant, you have to go at the top of that curve. That is a very visual way of telling your stakeholders, here's what matters for what your experiment is. Another thing you can do, and that's part of the answer to Javier, is p-values. If you run those tests 10,000 times and look, what is the p-value? The distribution should be flat. That's a very easy and visual test to do because p-values are uniformly distributed if they're properly done. So that's the key thing. And finally, you have an example of me taking all these code that you have here and literally pasting them into new functions to have computer manageable code. That is one version of it. And then you have examples of a much more serious code with unit tests, type checks, and things like that. That is typically representative of what you would expect from professional code. So that's the version. One thing I would love to end with is a quiz. If any of you are excited in getting more quiz, let me see if I can find my thing. Here it is. So our Mentimeter. It's a time quiz. So I don't know if everybody's ready. I've got 6, 7, 8. Can we go to 10 players? Well, that's so far to get more points. Why run a 50-50 split? Why not 1 10? You've got 45 seconds to answer. That way we'll end just right on time. Is it because there wouldn't be enough users if you did 90-10 splits? Is it the two halves on the same size, therefore it cannot be compared? So you shouldn't do a 10-15 split. Is it we can, but it will lower the power of the test? Or we do it all the time, but it's only for special tests?
The quiz screen is not visible.
You can answer the quiz with Mentimeter. You go on menti.com and type 84261274. And I've got a link. Cool. So most people have answered one of the true answers, which was we can, but it will lower the power of the test. You have an example in the code of explaining how it works. The two half on the same size, but yes, they can still be compared. This averages or just have to have different ratios, but that makes sense. The other true is that we do it all the time for special tests. So we do it for what's called holdouts, which is when you take head tests that we run for a very long time and we don't test on everybody. So Google has long-term holdouts for people who see zero advertising to make sure that advertising doesn't damage how people think about testing. Question 2. No, sorry. After 100 tests, only 20 are significant. How many are truly improving the service? I got one answer. Is it because data doesn't lie, so all 20 tests are actually improving the service? Do you use the 5% significance rule to say 20 times 5 is one of them is truly improving the service? Is it probably 4? and a couple of ideas were missed, or is it impossible for us to say? So people who've said all 20 that are like, it's not that reliable. They can all be good, but most of the time, some of them are not good. It's just there's a lot of element of randomness, even when you do reasonable statistical evidence. The 5% doesn't apply to the 20. The 5% applies to the tests that have no impact, which is presumably the 80 tests that were not significant. Out of those 80 tests, presumably 5% of them appear to be significant. And if you apply 5% to 80, you have 4. So if you have 80 non-significant tests, you probably have 4 of them that were significant. And so out of the 20, presumably around 4 were not significant. So we can say, but we have to apply logic around how many tests did we try that were not significant. People call it Bayesian logic in a way. That's not a bad way. I have an animation on the presentation that shows you a little bit how the numbers work for that one. If we change the significance threshold from 5% to 10%, which will have a lot of people asking you to do it because that is like the most common requirements, will the test be significant faster? Will the company improve and become faster? Is it possible that some of the tests will contradict each other? Or will it stop debate about increasing or lowering the threshold? Because you're going to have a lot of those debates. So if people say, oh, we should move the test, 5% is not enough. I've got example where p-value is 6%, 7%, 5.1, and I really want you to increase it to 10% so that those are considered valid. What would be the impact? Would the test be significant faster? Would the company improve faster? Would results contradict each other? Or would it stop debates about the threshold? The test would be significant faster, that is true, but the company would not improve because you would have more examples of like not great ideas that are put into production, so that's not really good. Some result will contradict each other because you have more false positive, so you end up with like results that don't really align. And I'm really sorry for the one person who said it will stop debates about the threshold. People will absolutely continue fighting about those. They will ask for 15, 20. You won't stop those debates. What can actually make tests more likely to win is to have better ideas, and that is a long and tedious effort. Once again, comparing to trapeze artists makes sense because it takes a very, very long time to be a good trapeze artist. And last questions. If we decide to retest all the others that we tested significantly positive, what will happen? A, it will have less impact, some of them non-significant. B, we'll see the same impact because testing is reliable. C, we will see more impact because there were good ideas that are proven in the meantime. Or D, we don't know. It really depends on the idea. Well, in practice, we'll see less impact. Some result might even not be significant. That is because of a phenomenon called regression to the mean. I won't have time to go into details, but that is a somewhat important thing to understand. It's hard to fight against, so it doesn't really have a lot of impact, but it's a good intuition to have. We could see roughly the same impact, but it's very, very unlikely. It does depend on the idea. I made this one as not true, kind of true is true. But I just, most of the time we see less impact if you have enough. Here's the leaderboard. Some people have amazing scores. So congratulations to Metal, Hulalap, Ambriel. Wait. Hulahop won. Congratulations. I don't know who Hulahop. Sakura and Metal also pole position. So thank you so much for participating. Thank you so much for your attention. And let me try to switch to my conclusion slide if I can figure out a way. That's the animation that I was planning on showing for the whole thing. That is a key thing about categorical insights and how they work. Here's a couple of future work and recommendation. But what's my key insight? But the key thing is that you understand how A/B testing work, both that it's part of a general system of a lot of people that are trying very hard to make sense. You come in that and you tell people that the baby is ugly. It's not the nicest feeling in the world, so be kind of really mindful of it. You really need to rely on your analysts to define good metrics. You really need to rely on data engineers to do 90% of the work for you, which is great. Your job is the difficult part of the job is to define good metrics. But there's a significant amount of understanding how the code work and the data manipulation work that is kind of manageable. But the good thing is, if you build A/B testing as a service, it's a service that people look once a week, so it doesn't really challenging as I was hoping to show into to made more service. Hopefully that session was interesting. I haven't covered half of what I was hoping to, so I'm really sorry about that. But I hope that I've covered most of the questions. If you have any questions, I'm available. Email bertilhatt@gmail.com. On LinkedIn, on Twitter, I'm on Facebook, but I already open it. I think I have an Instagram account. I'm on every single social media you can imagine. I would love to have your answers, your question, your frustration. If you want to call me for an hour and a half and tell me that your boss is a dick and that he's the worst hippo in the world, I will listen and take notes and use it for my future presentation. So please do that. If you want to tell me that Python is terrible and that the package management is unmanageable, I know. And I will also listen to your rant about that. I won't be able to fix it though. And finally, thank you so much for your attention. It's late on a Saturday night. I know that hasn't been fun for everybody to take a bit of time away from your off time, but I'm very happy you did. And hopefully we can all talk about amazing A/B tests you were able to find in the near future at a conference nearby.
Thanks, Bertil, for such an information-rich webinar. I mean, the number of examples that you've cited from real, your company, your experience basically is something that is invaluable, and we thank you for just a well-paced information-rich webinar, and hoping for many such webinars in the future. And thanks for your time as well.
Thank you so much. If you want ideas, I've got like future work slide that has so many ideas. There's so much more there, experimentation, than I was able to talk about this way. But that's for the next session. Hopefully everybody can enjoy their tea, and I'm gonna drink mine. Bye.
Thanks, Bertil. Thanks, everyone.